Fundada em 1966, a ABES está há 55 anos trabalhando pelo saneamento, pela saúde e pela qualidade de vida das pessoas. Junto com nossos associados, enfrentamos e superamos inúmeros desafios, mas ainda há muito a ser feito. O nosso objetivo é alcançar a universalização do saneamento, trazendo água tratada, coleta e tratamento de esgoto, drenagem de águas pluviais e coleta e destinação adequada de resíduos sólidos para todos os brasileiros, além da preservação do meio ambiente. Qual é o caminho? Todos juntos para chegarmos lá, com a participação do governo, das empresas públicas e privadas, universidades, profissionais, organizações do setor e da sociedade em geral. Para isso, a ABES São Paulo atua ativamente com suas 7 câmaras técnicas, fomentando o debate com foco e direcionamento nos temas relevantes. Despertando novas habilidades e lideranças, também conta com o programa Jovens Profissionais do Saneamento, voltado para jovens de até 35 anos que atuam ou têm interesse na área. A ABES-SP também atua por meio de 5 subseções, que possibilitam o desenvolvimento de ações e eventos regionais abrangendo todo o estado. Valorizando a qualificação do profissional, está sempre lançando novos cursos e outras atividades técnicas. Acompanhando as transformações impostas pela pandemia e o isolamento social, em 2020, a ABES São Paulo lançou uma nova categoria de treinamentos exclusivamente online, que atende a profissionais do setor em todo o país. Desde 2014, já foram mais de 1.100 pessoas capacitadas, nas modalidades presencial e online. A ABES São Paulo também promove eventos para fortalecer o debate e a difusão do conhecimento. No programa ABES Conecta, discutindo os temas mais relevantes do saneamento de maneira online. Com o Bar da ABES São Paulo, promovendo inovações tecnológicas, interação e troca de experiências, unindo palestras e happy hour. A ABES-SP ainda marca presença em diversos fóruns de participação, com representação nos conselhos e comitês de bacia e tem um amplo engajamento no setor, tendo diversas propostas já apresentadas aos governos em âmbito federal e estadual, e sempre se posicionando sobre os temas mais relevantes. Além disso, tem tido uma presença cada vez mais ativa na mídia, se destacando em importantes canais de comunicação. Comprometida com a transparência, ética e responsabilidade, a ABES Seção São Paulo está engajada em trazer ainda mais inovações, além de intensificar a participação dos associados e modernizar as formas de relacionamento. Venha fazer parte dessa transformação com a gente. Juntos vamos fortalecer a nossa ABES e o saneamento.
Bom, boa tarde a todos e a todas. Meu nome é Luiz Pladevall, presidente da ABES São Paulo. Queria agradecer primeiro a presença de todos e também do pessoal que está online com a gente, né? Em especial, queria agradecer aqui o Sérgio Palazzo, que é o responsável pela organização e que ele é um dos diretores de uma das nossas subseções e ele trouxe o tema que é bastante relevante e conseguiu organizar esse timaço, né, de palestrantes que nós vamos ter aqui hoje. Bom, hoje nós vamos falar do Evento Internacional sobre o tema Cruzamento de Redes de Serviços Públicos no Subsolo. Aqui todo mundo acho que trabalha com essas questões, né? E eu sou um defensor aqui que a gente precisa melhorar muito nossos cadastros técnicos, né? Eu estou há 42 anos no setor e a gente vê uma falta de integração das concessionárias, né? Para que a gente tenha uma coisa de qualidade, um cadastro que reflita a realidade. Temos muito o que fazer nesse sentido. Estamos realizando esse evento no formato híbrido e de forma presencial aqui na sede da ABES, com transmissão pelo nosso canal do YouTube. E também deixar claro que isso vai ficar gravado. Quem não tiver a oportunidade de ver todos os painéis aqui, depois tem condição de entrar no nosso canal do YouTube e assistir, ou assistir novamente. Hoje reuniremos especialistas em métodos não destrutivos, inteligência artificial e gestão de ativos para aprofundar o debate sobre o tema. Este evento é uma realização da ABES São Paulo e conta com o apoio da Abratt, Associação Brasileira de Tecnologias Não Destrutivas, e da Associação e Sindicato Nacional das Concessionárias Privadas de Serviços Públicos de Água e Esgoto, ABICOM. E queria agradecer imensamente os nossos patrocinadores, a Comgás e a Sabesp, que estão aqui colaborando para a realização do nosso evento. E agora apresento a vocês nossos convidados para este encontro internacional. Já falei aqui, o Sérgio Palazzo, na realidade ele não é um convidado, e sim o organizador do nosso evento, e ele é secretário da subseção Centro Paulista da ABES São Paulo. Samuel Ariaratan, especialista da Universidade Estadual do Arizona. Alan Leidner, membro do board de diretores do GIMMO de Nova York, Prefeitura de Nova York. Tom Isley, CEO da Bain Institute. Herter Hilmenberg, diretora do SFECF, um instituto dedicado à gestão de ativos enterrados na Universidade do Novo México. Otto Bailitigin, CEO da Reduct. Eric Sullivan, diretor da Sower AO. E Mark Bruce, presidente da Associação de Cruzamentos de Redes dos Estados Unidos. Muito obrigado a participação de todos. Thank you for your participation. Vamos iniciar a programação e esperamos alcançar aqui, com este webinar, um entendimento da importância dessas ocorrências aqui no Brasil, né? A gente vai olhar o que está acontecendo aí fora, o quanto as pessoas, os especialistas estão preocupados e o que a gente pode trazer para a nossa realidade aqui no Brasil. Sérgio, acho que agora você coordena aqui o evento. Muito obrigado a todos.
Boa tarde a todos e a todas. Pessoal que está aqui presencialmente, pessoal que está online. Em especial o pessoal que vai palestrar, porque nós tivemos aqui que enfrentar uma dificuldade enorme, porque eu tenho gente de diferentes fusos horários, né? Então nós temos um cara que vai ter que acordar às 2 da manhã para bater um papo com a gente, mas tenho gente em Los Angeles, em todos os lugares. Então essa organização realmente foi bastante difícil. Por causa disso, pode ser que tenha alguns problemas, mas nós não estamos preocupados com os problemas que a gente vai ter aqui, né? É uma oportunidade única e, então, ao decorrer da apresentação, pode ser que tenha alguma pane aí, mas a gente está disposto a encarar. Também queria fazer aqui uma rápida apresentação. Eu pensei assim: puxa vida, é um evento legal, temos uma adesão muito grande e seria uma oportunidade para deixar uma provocação, né? Então eu tenho trabalhado fora do país e tenho notado que em alguns países, inclusive aqui da América Latina, a gente avançou muito, mais do que até no Brasil. Então vou pôr uma rápida apresentação aqui, são alguns slides, para que a gente reflita sobre isso a partir de hoje. A minha primeira colocação é o seguinte: nós não somos muito bons na administração dos nossos ativos aéreos. Aqui a imagem do lado esquerdo, né? É uma crise institucional e organizacional que está acontecendo com as redes aéreas, né? Nós temos tido frequentes acidentes nessa área. E por causa disso, pensou-se e está se pensando já há 25 anos em tirar tudo que está no poste e enterrar no chão, né? Então eu tenho uma séria dúvida sobre a eficácia dessa ideia, porque se onde a gente enxerga está assim, imagine longe dos nossos olhos como é que vai ser. E ao redor do mundo, essa imagem de baixo é de Nova York. Essa imagem correu o mundo da zona que é o subsolo daquela grande cidade. E ali da nossa mesmo, né? Então eu quero deixar aqui uma provocação. A possibilidade de a gente atingir o que eu vou mostrar agora? Eu acho que há. Então, na próxima imagem, a gente está se valendo já das computações gráficas, né, do BIM, de todas essas tecnologias que a gente consegue estruturar o nosso arquivo, o nosso ativo do subsolo. Então, essa é uma imagem de uma rede, das redes existentes nessa região nos Estados Unidos. Essa outra dá bem uma ideia do que se pode fazer dentro das nossas instalações, todas elas, todos os serviços públicos. A próxima. Esse é um cadastro completo ao qual a gente pode ter acesso hoje, todos tendo acesso à mesma base. E por fim, um vídeo. Esse vídeo está sendo divulgado, já é aplicado na Colômbia, né? Então, eu sonho que a gente possa fazer isso. A Colômbia fez, né? Por que que nós não podemos fazer? Então, essa é a realidade de uma manutenção numa rede de esgotos, traduzida para uma imagem em 3D, numa computação gráfica, né? Baseada em todos os levantamentos que foram feitos, né? Então, o que vocês vão ver aqui hoje é de que forma eu posso captar os dados, coletar dados, para que o pessoal especialista nessa área traduza esses dados numa exposição desse tipo aí. Ok. Então, eu também queria ver quem que está já no grupo com a gente, Vinícius. Quem? Ok. Nós já temos 3 convidados conosco aqui ao vivo, né? Alguns entrarão no horário da palestra. So I want to say good morning for some of you, Sam and Eric. And which is the other one, Vinícius? Quem é o terceiro? Alan Leidner. O Alan Leidner, good to see you or hear you here. And we'll be soon talking about. So, okay. First of all, I will give you a few minutes, Sam, Eric, and Alan, to say good morning for the group here and online. So we can start with Sam. O Sam vai dar alôzinho para nós.
Good morning. It's a pleasure to be here, but I wish I were there in São Paulo with all of you. But it's great that you're all together for this important topic, and I look forward to listening to all the presenters and engaging with you during this. And I also look forward to my next trip to Brazil. Thank you.
Alan Leiden.
Such a great distance. It's warmer there than it certainly is here in New York City. Gizmo, by the way, is the Geospatial Information Systems and Mapping Organization of New York City. It's a New York City user group, and we participated very actively in the GIS response to 9/11, and you'll hear that in the presentation. So thank you for having me, and hope you enjoy what I have to say.
Thank you. Bom, o Samuel Ariarati, né, já esteve várias vezes aqui no Brasil com a gente, né? Nós já podemos dizer que é nosso colega. O Eric não entrou, mas mais tarde ele vai acabar falando com a gente. A palestra dele é mais no fim. E o Alan Leidner é da Prefeitura de Nova York, né? E ele é o cara que foi responsável pelo escritório de crise montado no dia que as torres gêmeas foram derrubadas, né? Então havia uma grande preocupação, lógico, com todas as pessoas que morreram naquele evento, mas o prefeito de Nova York encarregou ele de resolver o problema das tubulações que estavam no subsolo, que não eram só naquela região do colapso, né? O sistema todo, que abrangia vários quarteirões, colapsou. Então, nós vamos ter oportunidade de ouvir a palestra dele, que ele montou esse escritório de crise. Ok, nós vamos passar para a primeira apresentação, que é a do Samuel Ariaratna.
Ô Sérgio, só para a gente comentar, explicar a dinâmica do evento para todo mundo, acho que seria legal. E aí falar sobre a filipeta que está nas sacolas para dúvidas, né?
Ok. Então, o evento é o seguinte, para facilitar a parte de idioma, os palestrantes, em primeiro lugar, mandaram suas palestras. A ABES, num esforço fantástico, legendou em português. Então, aqueles que tiverem qualquer dificuldade com o inglês poderão assistir a palestra legendada. E nós estamos dispostos aqui a aceitar perguntas, tanto de quem está online, pelo chat, como também de vocês aqui presencialmente. Os que estão aqui presencialmente preencham a papeleta que está aí, foi distribuída. Ela está lá atrás, ela recolhe e passa para o João ali, que faz a coordenação. Os que estão nos assistindo online podem colocar perguntas no chat também. O João Lorenzi está ali e vai fazer a coleta. Nós não teremos tempo para muitas perguntas ao fim de cada apresentação. Eu vou tentar fazer alguma seleção ali durante a apresentação, se tivermos, e ao fim a gente tenta responder mais alguma coisa, mas nós prometemos, e os palestrantes também, que todas as perguntas serão atendidas posteriormente por e-mail. Ok?
É isso aí, ótimo.
Então, a palestra do Samuel, por favor.
Hello, my name is Dr. Sam Ariaratnam, and I'm a professor at Arizona State University. Today I'd like to give my presentation on reducing underground utility strikes resulting from horizontal directional drilling. If we look at the buried infrastructure growth, in the United States, in terms of buried underground infrastructure, we have more than 56.3 million kilometers of these utilities. And due to population growth and urban development, this number continues to increase every year. If we look at the nation's underground networks, a lot of inadvertent striking of utilities, which happens every minute in the United States and equates to about 500,000 annual utility strikes, according to the Common Ground Alliance. Some of that striking is a result of horizontal directional drilling. Some of those strikes are open cut excavation type equipment. But unfortunately, with horizontal directional drilling, we're not excavating, so we're going underground, and sometimes we can hit a utility like a sewer lateral and not even know that we hit it until much longer years later. And the primary impacts of damaging an underground utility include outages, explosions from gas, fires, flooding, disruption of emergency services, evacuation, downtime for businesses, and a lot of other issues. Some secondary impacts are potential injuries and death, criminal investigations. We could have contamination of contaminants, project delays, financial liability, extra work orders, construction claims, higher insurance, and of course, bad publicity of these types of occurrences. The concept of subsurface utility engineering is really important, and it's the safest method to document the location of underground facilities prior to construction. And so when you look at before construction, there's different types of subsurface utility engineering applications. The most common would be the vacuum excavation. We do things like centerline profiling, we do utility mapping and records management, preliminary engineering design, cathodic protection, non-destructive methods, and soil sampling are other types of subsurface utility engineering. There's a couple of great standards that the American Society of Civil Engineers has out. One of them is the 3802, the standard guideline for the collection and depiction of existing subsurface utility data. It's a very famous one. It's one that's utilized quite a lot. A newer one is a subsurface utility engineering for municipalities. And so it looks at pre-qualification criteria and scope of work guidance. A study was done many, many years ago at Purdue University, and it looked at the value added, and it found that for every $1 spent on subsurface utility engineering, the resulting savings was $4.62. And that's a really big savings if you think about putting in that dollar and getting the large savings of almost 5 times the savings, because of the fact that we're identifying those utilities and don't have those costs that can occur from striking or hitting a utility. We have 4 different quality levels of subsurface utility engineering. Quality level D is it's the lowest level, and that's really looking at existing records or oral recollections of what could be out there, to utility level A, which is doing precise horizontal and vertical locations, looking at by actual exposure and measurement of the utility, so you know exactly where it is. And so within that range from A, B, and C are the different quality levels of subsurface utility engineering. Some of the industry issues that we find in utilities are, lack of planning. We tend to be in a hurry, so sometimes what that results in is doing the job without really doing proper planning or investigation. A lot of times we have outdated as-built or incorrect blue stakes or utility markings in the area. A lack of competent contractors. Sometimes the contractors, they just don't care, or they don't really understand, and they proceed to do the work without really identifying those existing utilities. Sufficient equipment concerns, utility damages, and poor communication is a big part in the industry that we worry about. As I mentioned previously, excavators or horizontal directional drills tend to be the construction equipment that's most used for installing underground utilities, and subsequently they're the ones that are more likely to strike a utility. With horizontal directional drillings, this is a crossbore. You can see there's a gas distribution line within a sewer service lateral. And the problem with that is it could cause a blockage, and then when a plumber or somebody comes out with a mechanical tool to try to dislodge whatever the blockage is, they nick the gas line, cause gas to go up the sewer lateral into the house, and as a result you could have explosions. Here's another example of a cross-bore utility. It's a gas line within a sewer line that we have to be concerned about. A couple of major cases here that resulted in very significant explosions that occurred. I was actually involved as a consultant on all of these cases. One was in the one in the top left-hand corner was a gas explosion that resulted in the destruction of a restaurant in Kansas City. The one on the top left is a gas explosion that blew up a coffee shop and other businesses surrounding it in Durham, North Carolina. And the one at the bottom is an explosion in Wisconsin in which a firefighter died during that explosion. Here's the consequences as well. This is an explosion in Minnesota. You can see this house was completely destroyed from a cross-board utility where gas seeped up through the service lateral and blew it up. Here's one in Maine. This is the North Carolina one, the coffee shop I mentioned from the explosion. This was one in Colorado where actually the sewer line that was hit was actually a fair distance away, and basically the contractor hit a sewer and gas line. The gas went through the sewer and it went quite a distance and then blew up this particular house, killing a lady. This is one in Florida, a similar situation where a contractor was installing a line, hit a gas line that went into a sewer and went down 2 blocks and blew up this house and killed a 22-year-old young man and badly injured his father. So we can minimize our risk by conducting on-site field investigations prior to boring. And that's one thing I really advocate, is that go on site and look around and see what kind of utilities are in the area that you're doing the excavation in, whether it's using an excavator or using a horizontal directional drill rig, and try to identify some surface features or things that you might identify that there could be a utility. We do pre-bore checks of our electronic locating equipment. That's really important, particularly when we're using walkover equipment that rely on electromagnetic signals. And so we have to make sure that through that area that we're going through, that there's, try to identify if there's any sources of interference, active or passive interference, that could cause some sort of disruption in terms of the depth readings that we're trying to get during the case. On the right-hand side is what we call a 10-foot test. And so basically what we're doing is making sure that the sonde or the transmitter that's below ground by the drill bit is actually reading the locator, the receiver properly. And so we lay it out 10 feet, take a reading, and hopefully that reading is 120 inches or 10 feet, and that means it's reading properly. Now, should it not read properly, then what we do is we do a calibration sequence on the locating equipment to try to match it back up together. In the U.S. and most of the world, basically adheres to the American Public Works Association utility marking color code. So if you see red, it's going to be an electrical line, yellow is gas, orange communications, blue water, etc. Those are, when you see those marks on the ground, that's indicating that those utilities should be underneath those marks. It's also important when we're excavating to understand what the tolerance zone is. And so when a locator puts down a locate flag or a paint mark, what they're saying is that their utility is somewhere within a tolerance zone of 24 inches plus half the width of half the diameter of the utility. And so you have to make sure that within that tolerance zone, that's where you need to identify where that utility is. And so, for example, if you have a locate flag and you dig down to try to find it, you can't find a utility there. You need to go within that tolerance zone, that 48 inches plus the diameter of the utility, and within that range. If you're outside of that range, and if you're trying to excavate there, it's not your responsibility to have to locate it. The other thing is if you're crossing a utility, it doesn't matter what the tolerance zone is. You need to pothole down and identify the exact utility that you're excavating, and follow that utility, follow your pilot bore and your pullback of your reamer and your product pipe by looking through the window that you've created. And that's looking at confirming the location of existing utilities. And we use the most common approach is using a vac truck. And so that vac truck, you can cut out a little patch of the pavement and then excavate, and you won't damage that existing utility, and then you identify exactly where it is. And so when we're crossing it or we're going parallel to it, we know where that utility is. It's an example of a small pothole, and you can see identifying that utility that's underground. T is the top, so it's 2.81 feet deep, and B is the bottom, it's 4.45 feet deep. And so you're actually physically measuring down to know exactly where that utility is. Design and planning, as I mentioned before, it's really important to identify site-specific hazards using subsurface utility engineering and looking at existing utilities, existing structures, what's geotechnical investigations. We use bore planning tools, electronic tools that can really help out during the process, and enables HD crews to evaluate actual deviations and make adjustments during the construction phase. Bore planning software is available for HD design, such as this one here. This is an actual one that a contractor used, where they can actually do the planning ahead of time. Like I said, with another similar application here of HD bore planning. And so that really helps. You can do every rod underground, helps you to plan, and then you can superimpose the actual bore path that was taken, which is captured within the receiver. I mentioned site investigations. Walk the site. Look to see if you see manholes. If you see a manhole, then that's a good indication that you probably have sewer line coming out of there, and you can actually go down and see how deep it is. If there's an electric transformer box, there should be electrical lines coming out of there, so you should see some red marks out of there. Gas barbecues could indicate gas lines. Road repair marks, like in this case, obviously some repair was made to a utility, so there should be a utility underneath there. And so any kind of evidence of existing utilities is really critical to look at. Some sources. This is the Horizontal Directional Drilling Good Practices book that myself and Dr. Bennett were co-authors of. And this is actually the 4th edition of the book, and that has been translated into Portuguese. So if you go to Abratt or ABES, you can get copies of this book or purchase copies of this book that will give you a lot of good information on proper procedures and practices when you're looking at horizontal directional drilling. A couple of final thoughts. I think it's really important. The one-call system that identifies where the utilities are, it's really the last chance to prevent damage. And the best chance is to start damage prevention in the planning and design stage with long-term asset management strategy for determining and maintaining baseline conditions. And so what I advocate for is that in the planning and design stage, we identify where these utilities are. And so when we do the design, we can create a design that is not in conflict with any of these existing utilities as well. There's a lot of excellent resources out there. Abratt, the North American Society for Trenches Technologies, 811, which is the one-call system in the U.S., Common Ground Alliance is a really big organization for damage prevention. The International Society for Trenches Technologies and the American Society of Civil Engineers are all organizations and associations that are big advocates for damage prevention and safety, and I think that they're excellent resources to explore. This is my contact information, and please reach out to me if you have any questions related to damage prevention or horizontal directional drilling aspects at all. And you can see all my contact information is there. So there's various ways of getting hold of me in that. So I'd like to thank you very much, and obrigado.
Okay, Sam, we have a question about what are the standards for steel pipe for directional drilling in U.S. or worldwide?
For design of steel pipes?
So a steel pipe in directional
Yeah,
drilling.
so PRCI,
Standards
the
is-
Pipeline Research Council International, they have developed some standards that they use, some guidelines for designing of steel pipes. So that's available. For plastic pipe, we look at the ASTM 1962 as the standards.
Sam, we would like to see you at the end of this meeting for the round table. Thank you very much for your presentation.
Great, thank you.
Havia uma pergunta no site a respeito de normas para aplicação de tubos de aço com furo direcional. Nós temos algumas, mas basicamente a maioria são para os tubos de polietileno que foram instituídas pelo PPI, que é o Plastic Pipe Institute, é um instituto das fabricantes de tubulações de plástico, que me autorizaram a traduzir. Eu vou disponibilizar depois no site da ABES o documento traduzido, é gratuito, e vocês podem baixá-lo. Então, nós temos sim uma norma para o Maxi HDD, são para as grandes travessias, né? Aqui hoje está aqui conosco, ontem foi feita uma travessia com o Marcelo e concluiu 3.100 metros, 16 polegadas, era para ser em 24, viramos para 16 para atender o cliente lá e o tempo, né? O Brasil, então, já faz perfuração direcional com o mesmo nível e padrão de qualquer lugar do mundo. Sofremos muito aqui nos diâmetros pequenos para telecom e outras redes, né, onde há a maior concentração de equipamentos, mas é importante mencionar isso aí. Também queria fazer uma notinha rápida aqui. A Melissa, que é da Comgás, contraiu Covid. né? Então está assistindo a gente de casa. Ontem ela estava na dúvida se a gente ia ter lugar aqui. Nós tínhamos mais inscrições do que lugares. Mas, como sempre no Brasil, sobraram alguns lugares. E aqui está conosco o Jorge, viu, Melissa? Que ela estava preocupada que você viesse. O William queria vir também, não veio, acabou tomando outro destino, né? Então, obrigado aos que participaram com a gente até esse ponto aqui. Nosso próximo apresentador é o Alan Leidner, que eu mencionei para vocês, que é o que montou o escritório de crise para o atendimento das torres de Nova York, né? Eu tive a oportunidade de conhecê-lo ano passado e depois da apresentação dele eu vou fazer alguns comentários. Nós vamos colocar a apresentação do Alan Leidner.
Everyone, greetings from New York City. My name is Alan Leidner, and it is an honor to be addressing you. Today I will discuss the GIS response to 9/11. And to start things off, I just want to say that I represent GISMO, which is the New York City Geospatial Information Systems and Mapping Organization. We are a user group, and we have been fighting for the use of GIS in New York City since 1990, when we were first organized. Is just a quick shot of, on your left, some of the destruction caused by the attack on the World Trade Center during 9/11. And to the right, you're seeing a number of GIS practitioners in the Emergency Mapping and Data Center responding and providing support to the response community using GIS. The history of GIS preceding 9/11 goes back a ways, and it's important to understand that before 1995, there were numerous GIS systems in New York that were unrelated to each other. They were in their own silos, and when the maps were brought together, they didn't really overlap, and so you missed a lot of the data collaboration that you might have had if it was an enterprise GIS system. We just didn't have it, but we recognized that we needed it. Other examples of some of the GIS work we were doing was, aside from street center lines and parcels, and was the city water main mapping project, which was creating a infrastructure layer of the water mains of the city. So working with GIS upstate to map the entire watershed of New York City. In order to get enterprise GIS in the city itself, we had to get some money firstly, and then finally got aerial photography and did feature extraction of probably millions of different features between 1995 and 1999. The results of that were imagery over which the streets were overlaid, and the parcels and the buildings, and ultimately hundreds and hundreds of other layers. So we had a completely integrated set of data sets, all that had spatial identifiers that could link them to a common base map. And this is what we call basically, another way of looking at it is that if you take your key location indicators in a jurisdiction and you relate them to each other based on a common base map, you can then relate all the data sets that are associated with each of those geographic identifiers, and therefore all the data is interoperable regardless of what the location indicator might be. And we, at this point, have thousands of data sets that relate to each other in New York City. You know, this can also be seen as far as the underground is concerned, and infrastructure. because by relating each of the different utility layers and the infrastructure layers of the city, you basically can bring together the data associated with them, and once more have a very powerful utility where you can share between infrastructure organizations data so that it overlays, and you could do much better planning and emergency response and just plain construction work. We get to the attack on the World Trade Center itself, which you've seen graphic. And this, it was terrible, truly terrible. What I want to show you here is based on the fact, since it happened in 2001, actually we had the city's base map distributed to all the city agencies. So almost as soon as the first impact of an airplane on the World Trade Center, our fire department was able to produce a series of maps that allowed response teams to go to the site and know where they were oriented on the World Trade Center, because many people coming in for rescue operations were not really that familiar with Lower Manhattan. And so these maps were a first product that were turned out literally within the hour of the attack on the World Trade Center. Ultimately, more sophisticated maps were developed, often in collaboration with US FEMA, the Federal Emergency Management Agency, and quite sophisticated methods of performing search and rescue operations and being able to know where you were the day before and where there were dangerous areas that you needed to stay away from. The fire department and FEMA also developed an application that allowed for improved placement of cranes that were being used both in search and rescue and to clear the area. We also were collaborating not only with the federal government, but with our state government colleagues. They were up in Albany, New York, about 140 miles away, but they were able to organize the flying of aerial photography, imagery, oblique angle photography, LiDAR, and infrared, and were sending it to us on a regular basis. And that took a big burden off of us. It just helps so much to have the federal, state, and local governments working together to coordinate the data gathering and then the analytics from the LiDAR, which was the imagery of the destruction on ground zero, and you can see the darker orange is where the collapse went as much as 50 feet below the street surface, and you could see the fragments of the buildings that were still standing. Picture of, you saw it a little earlier, but it's a picture of the Emergency Mapping and Data Center, which was organized within 24 hours of the collapse. Part of the problem was that the emergency operations center of the city was in the World Trade Center, and so it basically was inoperable, of course, and we immediately had to move operations ultimately to Pier 92, where we had a lot of space and were given an enormous amount of room to spread out and bring in our staff, which numbered about 75 plus people, technicians from the area, from Gizmo, working 24/7. That's how intense this operation was, and we produced thousands of images and maps and analytics for the entire response community. Shot from another view of the to the lower right is the intake station, where people in the response community could come and ask for maps. They might order a map, as you're seeing on the upper left, by number, depending on the theme that they were looking for, and they could ask for customized maps. And we were literally doing hundreds of these maps on a daily basis for the response community. Example of the data we were collecting as the requests for information came in. Another thing we managed to organize was the inspection of the red zone, which was the area that was most affected by the building collapses. And the buildings department needed their inspectors to go out and inspect all the structures south of Canal Street, or in the colored zone that you see on the left side of the screen, and inspect their elevators, their ventilation systems, their structural integrity. And we very quickly developed a mobile application that allowed the collection of that data. And on that mobile application was the city's base map. So every structure was on the base map, and it could be tied to a database which indicated any damage and a risk to any of the buildings still standing. Of the use of mobile handheld devices in action on site. Some of the map output showing the classifications of each of the buildings that were surveyed. This was a very vital application. In fact, handheld applications were pioneered here for the city, and it was the first time we were using this technology. So on a regular basis, producing maps that showed where people could or could not travel in Lower Manhattan. So you could see there was a no access in the red zone, no pedestrian access in the orange zone, and pedestrians were allowed to go in the yellow zone. This map was changed on a daily basis as increasing amounts of area were opened up for public access. One of the biggest operations we had was the understanding of exactly what was going on beneath the street, the utilities, the geology, some of the geotech structures that were down there. And for that, we had to call together, really for the first time, all the organizations in the city that we could find that had infrastructure elements under the ground. And so you see a lot of acronyms there, but we had our electric utility, our gas utility, our steam utility, our transit authority, our water and sewer agencies, the Army Corps of Engineers, which is the US government's engineering agency, the Port Authority, and so on. So we had to bring everyone to the table. They had not really faced each other before in the past, but this emergency obliged them to do it, and we organized the deep infrastructure group based on that. And we asked them for their information so that we could bring it in, relate it to our base map, and have that data interoperable as recovery was part of the product coming out of the deep infrastructure group was a daily mapping of outage areas in Lower Manhattan. Here you see no electric service, no telephone service, no water service, or indicated by their own color code. Those maps changed on a daily basis. This was very essential to give a common operating picture to all the 24 or more agencies that were in the area working their own particular mission. This is some of the material produced for the Transit Authority, which had transit tubes running under the World Trade Center, and you can see very graphically the collapse of the tunnels underground in the World Trade Center. Mapping and aerial photography and imagery done so that the Transit Authority could get a good idea of exactly what had happened. Further analysis in terms of the various elevation of the different levels in the subway system, from the street, from the entrances, down to the turnstiles, down to the track levels. So a big problem with the slurry wall that encased the World Trade Center, which was very close to the Hudson River, and there was a real threat that due to the damage and the collapse, that slurry wall that protected Lower Manhattan from the Hudson River might give way. And so there was a lot of engineering analysis and shoring up done. using, of course, the base map and the engineering drawings from the World Trade Center. So captured infrared photography to see where the fires were burning underground. This was absolutely essential because we wanted to safeguard the fire and emergency response personnel who were working on the pile so that they would avoid the hot spots. The imagery, the infrared imagery, was used to help locate where there was a 200,000 pound tank of Freon gas, which was used for the air conditioning system of the World Trade Center, which was underground and surrounded by fires. And we needed to understand where the fires were in relationship to the tank so that the firemen could put out the blaze in the immediate vicinity of the Freon tank. And some of you may know that when Freon is subjected to high heat, it can turn to phosgene, which is known as mustard gas, which would have potentially produced a secondary explosion and the release of poisonous gas across much of lower Manhattan. It was a good thing we found it. More of the analytics that we had to bring to bear to find that tank, and in the lower right, you can see that quite sizable tank that was filled with Freon gas, but ultimately it did not explode. It was brought to the surface and it was emptied of Freon. Bigger blow up of it. There's plenty more about 9/11, and the number of slides could have been in the hundreds, but I showed you a selection. I know that we have a little limited time, but I also wanted to talk to you about after 9/11 and the fact that 9/11 impressed upon us the importance of mapping underground utilities, underground geology, and anything that was underground that could have bearing on what was going on the surface. So here is just out of a magazine article that you could access by Googling Bloomberg Business Week magazine, and nobody knows what lies beneath New York City, and you could read the whole article, but we became very eager to make sure that the city continued on its path of mapping the underground and bringing together the different utilities to talk to each other, compare notes, and share data. It was not smooth sailing. However, there were advances. The MTA mapped in 3D or 2.5D all the 600 or so subway stations in the city to maintain common operating picture and to manage any events that might occur in subway stations underground. So that was a big success and an important addition to our data sets. And you can see how the base map on the right was used to overlay as an underlay for station drawings that were engineering drawings by the MTA, and they were oriented, sized, and placed on the base map and became a base map layer as a result, and so could be seen with all the other base map layers, which was enormously powerful and useful for the Metropolitan Transportation Agency. We started to work with the Open Geospatial Consortium, which is an international body for data standards, because we felt that it would facilitate the development of the underground map of the city if we had a data model that could fit in all the key data sets that we wanted to include. And so you see on the left the different networks that we were interested in capturing data about, and the use cases that would be how that data would be used to reduce strikes, accidental strikes, to reduce change orders and unexpected obstructions when doing major construction work and excavation work, for emergency response when you had to know what was underground quickly because something was going wrong, like an explosion or a water main break, and for longer range disaster planning and then response, because New York has been hit by its share of disaster events, from extreme flooding to, of course, the terrorist attack to blackouts. There were a lot of public safety and cost-saving reasons to want to do this, and we started a 6-year effort with the Open Geospatial Consortium to actually create a data model for use not only in New York City, but around the learned about the underground mapping efforts being done in Scotland and Flanders and in the UK and a number of other countries, and that went into our work with OGC. Access the work being done by the American Society of Civil Engineers, their ASCE 38 and 75 as-built standards and SUS standards for their features and their attributes to add to the model that we were building, at least at this stage, a conceptual model of the underground infrastructure. I think MUDI stands for Model for Underground Data Design or Data Definition and Integration. There you go. So this has now come a long way. The MUDI model is now being used by the UK, the entire country, to map their entire underground infrastructure. It's a big project, but they're using MUDI to do it because they did the cost-benefit analysis, and it, for them, pays off. And then about a year later, New York City committed $10 million to map its underground, and that's just getting off the ground. It's called 3D UG or 3DUG project. So we're doing it in New York City as well, and I know that Canada is visiting the possibility of doing it, and there's interest from other countries like Japan as well, and maybe Brazil will be interested. We're certainly more than happy to consult with you and to support you if that's a path you.
Ok. Nós tínhamos uma pergunta do Diego Santos no online. Eu acredito, Diego, que a sua resposta apareceu logo depois de você ter perguntado. A pergunta dele era se as redes em Nova York estão todas consolidadas num único documento, né? Então deu para ver ali que realmente temos vários shapefiles e as redes estão sendo lançadas, né? Eu queria voltar com o Alan Leidner, é possível? Alan,
yes.
When we were together in New York, you mentioned that you get those $10 million a year to identify all the pipelines underground in New York. How is that today?
Can you hear me? Are you good? It's $10 million total, but these sorts of projects always add money as time goes by. And it's not creating the data new. It's getting the best data that currently exists at the different utilities and the city agencies that maintain infrastructure layers, and adjusting it and registering it to the base map and putting it into a system. So there does need to be some data creation, but a lot of the data creation is already done. The big problem has been bringing everyone together to share the data and to be willing to share. Even in a secure environment, they've put up a real fight to being put in a position of having to make their data available.
Okay, thank you very much. I hope to see you again at the end of this meeting. And for sure, Brazil will improve the needs of doing what you're doing down there.
I hope you do.
Here in Brazil, sure.
I hope you do it quicker than we did.
Então, ele agradeceu aí, disse que gostaria que nós fizéssemos aqui mais rapidamente do que eles fizeram lá, né? E então eu tive a oportunidade de conviver com ele lá o ano passado e exatamente tendo em vista o que eles já teriam feito 22 anos depois. E aí eu falei, eu não quero mais sair de perto de você, porque com 10 milhões de dólares por ano para identificar e mapear uma rata, depois de 220 milhões de dólares, né, com segurança, você sabe tudo a respeito do subsolo de Nova York. E ele respondeu o seguinte: não sei nada ainda. Sei um pouco mais do que eu sabia na época. E a razão principal ele explicou aqui agora, né? Eles ainda estão tentando trabalhar com os dados existentes da época. Quer dizer, não há necessariamente um trabalho para buscar mais redes do que eles já conheciam na época. E a principal dificuldade, é lógico, é uma reunião de todos os concessionários de serviços públicos, né? Como ele falou na apresentação, só se encontraram pela primeira vez depois que esse documento foi gerado. Tem mais uma pergunta, por favor? Bom, aqui a pergunta... De quem é a pergunta? Sua. A pergunta é a seguinte: as concessionárias que operam lá projetam as redes com mapeamento das interferências ou o mapeamento ocorre na véspera da obra, quando há a elaboração do plano de furos? Bom, essa é uma pergunta recorrente no mundo, viu? Não é um problema brasileiro. Hoje lá, eu posso responder, eu vou explicar por que eu estou respondendo. Hoje lá é feito sim um levantamento anterior ao projeto. O projetista é responsável por resgatar essas informações. Sem elas, como é que ele projeta uma rede passando pelo meio de tantas outras redes? Então, hoje, nos Estados Unidos, eu vou falar dos dois documentos que a gente tem aqui, mencionados nas duas palestras. O indivíduo que projeta é obrigado a fazer o resgate, né? Então, mas acontece ainda o que você mencionou aqui e que acontece bastante no Brasil. Eu também fui solicitado a mencionar aqui as duas, a nossa legislação, a nossa norma de método não destrutivo para o furo direcional, né, que é a 17004, é a nossa primeira norma, né? Então já temos sim condições, inclusive, de acionar o empreiteiro que estiver executando uma obra fora das condições previstas na legislação. A norma da BNT dá um poder, vamos dizer assim, jurisdicional. O indivíduo, você pode ir à delegacia de polícia, o Marcelo estava aqui falando de algumas experiências já, registrar um BO e comunicar o indivíduo que está executando a obra fora dos padrões, e ele vai responder civilmente por aquela ocorrência, né? Então, pelo menos isso a gente já tem no furo direcional. Ele mencionou, tanto o Sam quanto o Alan mencionaram a legislação da Associação dos Engenheiros Civis dos Estados Unidos, que é a ACE 38, né? E a ACE 75. Essa ACE 3802 que o Sam colocou ali, ela foi emitida logo após o acidente das redes. Então a Associação dos Engenheiros Civis descobriu que não sabiam nada a respeito do subsolo de Nova York. Então, por causa disso, se reuniram e a associação redigiu esse documento que está disponível para quem quiser entrar no site da associação, o 3802. Passados 20 anos, eles concluíram que o documento não ajudou quase nada, né? Então eles lançaram agora o 3822 e lançaram em complemento o 7522. Então a ideia desses dois documentos é o seguinte: primeiro eu preciso aprender como investigar o que está no subsolo. Então nós notamos que há uma dificuldade e um pouco conhecimento de como investigar. Tem que ter um ensinamento de como investigar as redes. Uma vez investigadas, nós precisamos de uma orientação padronizada de como registrar o que a gente encontrou. Então, o documento 3822 faz o registro, faz a investigação e o registro. E no documento 7522, ele diz como que eu documento e compartilho, porque os nossos cadastros são compartilhados entre todos os concessionários que querem instalar uma rede de subsolo. Então é bom que esse compartilhamento também tenha uma orientação. Então o segundo documento orienta como que os concessionários compartilham um documento padronizado. Então esses dois documentos estão em andamento aí. Eu vou dar prosseguimento aqui, nós vamos fazer um intervalo depois de 5 minutinhos, para não perder o horário, para que vocês possam ir ao banheiro, fazer uma ligação, né? Muito bem, nossa próxima apresentação é feita pelo engenheiro Tom Isley, ele está na linha já aí. O Tom Isley é o CEO e presidente do BAMI, né? É um instituto, a abreviação é de Instituto de Gerenciamento de Redes Enterradas. Então, foi necessário que se criasse um instituto de redes enterradas para que a gente tivesse um grupo de trabalho focado nesse tipo de problema que é a gerência dos nossos ativos. Queria dar um ok para o Tom Isley. Hey Tom, good to see you again. Thank you very much for joining us. I'll give you a few seconds, if I may, to make your presentation introduction. Then I put your presentation on live.
Okay, sounds good.
A apresentação dele tem uma diferença das apresentações anteriores, certo, Vinícius? Nós vamos subir daqui a apresentação dele ou ele sobe lá? Ok, Tom, you can share your presentation from there, okay?
Okay. Okay. Can you see the screen now?
Yeah.
Okay. I think we're ready to go, and it's my pleasure to bring you greetings from Purdue University in Indiana, USA. And I wish I could be there with you in person, but sometimes we have to use technology to help us. But it is my pleasure to be able to talk with you for the next few minutes about asset management. We've heard asset management refers to taking the principles and practices of asset management and trying to apply it to our underground infrastructure, particularly our piping systems. And I want to put this in perspective of what it means as being a major component of protecting against cross bores. And so, yeah.
Can you put on full screen presentation?
Yeah,
okay.
Sure. I thought
Thank
it was
you.
only, let's see here. Where is it at?
Hey, good to see you. Just saw this. Let me stop sharing. Actually, let's see. Do you see it now? Full screen.
Is it full screen now? Okay. All right. Okay. So we'll get started here. I'd like to first of all mention that it's here at Purdue, we provide administrative technical supports to an organization called BAMI, the Baird Asset Management Institute, that you were introduced to a little bit earlier. And the things that we're really trying to do is work with owners of underground infrastructure to help them manage their underground utilities more proactively. And we do that with a team, excuse me, here at Purdue. And I'm not going to go into the details of all of these individuals, but all of them represent a specific area and carry on a major responsibility for accomplishing the things that we do here at Purdue with the with BAMI. Just a little bit of information on BAMI. It's been around a little over 20 years. It started out in the city of Atlanta, trying to help the mayor and the commissioner up here in the right-hand corner, try to figure out how to move the water infrastructure program in Atlanta from having major problems. They were under a court order, a federal court order of about $4 billion to bring the system up to minimum standards. But the mayor's vision was to move it to being first in class. And so that was my job. My job was to, as a senior advisor to the commissioner, as shown in the picture up there, was to try to figure out how to do that. And that led us into realizing that it's not just having technical solutions. It's not just knowing about the problem. It also involves being able to put that under some type of a comprehensive risk-based asset management program. So we have moved forward in the last 20 years in developing educational programs, in developing the structure of BAMI, and moving on to developing a global Congress that we had last September. So I have to give credit to these two individuals that were shown in the picture in the last slide, and mention that the mayor's vision there was to accomplish what's that last sentence there, to actually develop a world-class water program. And that's basically what all, I think, water utilities are really striving for, is to do the best job that they can. I was very fortunate to work with these two people because it really opened my eyes to what's really involved in having the responsibility of ownership of the underground infrastructure and what we need to do to try to improve it over time. After BAMI got started, we got an EPA grant. And this grant was 2 years. It went from 2006 to 2008. And it really gave us the fundamentals of what we needed to do to develop asset management programs. And from there, we were able to develop 4 major programs. These are all online courses. The first course gets into providing an overview, and then how to develop a plan, how to implement a plan, and how to finance a plan. So as a result of moving forward as a nonprofit organization, getting the EPA grant, we were able to develop these courses. And people from 16 countries now have actually been involved in taking these courses. But after we got these courses developed, we were also challenged with putting together a certification program. So we established a certification board under the BAMI board in order to implement this certification program at 2 levels, at the associate level and the professional level. So we have people now that's getting certified as associate water asset managers and professional water asset managers. So what we have now, as a result of the work that we have from many, many volunteers and from the people that's working with me and my team, is we have a structure in place to support utilities in developing asset management programs. So not only do we have the online program that anybody can take anywhere in the world at any time, we have by invitation been asked to come in and teach these classes, 4-day classes, in various places. A couple of them have been with municipalities where they've asked me to come in, ask our team to come in and teach the courses, and some of them have been with state agencies, but we put these on from time to time as a classroom because there's a lot of people that would like to just sit down and go through all 4 courses in one setting. So we have a team of instructors that come in and do that. I would like to mention that we have the structure in place that deals with various aspects of asset management. This column in the middle here gets into talking about let's see here. Here we go. These are the various components of asset management in water and oil and gas. In addition to having this committee structure, we have international liaisons. Sergio is the liaison for Brazil, but all across the world, we have liaisons that we work with to make sure that we not only are providing them with resources that we might have, but also drawing from their expertise. Here's some work that we've been doing in China. We've done a lot of work in China over the last, actually in Asia over the last 20 years. And here we are actually establishing a branch of BAMI in China. So here's the journal that we have that continues to keep the members and those that's interested up to date with what we're doing. We have the first issue this calendar year coming out next week, but this particular issue here recognizes our 20th year anniversary, and this was done in celebration with the Global Buried Asset Management Congress that was in Chicago in September, and so we're very proud of that. It was the first time that we were able to bring in international leaders to try to establish what is the state of practice worldwide, where do we need to be in 5 years, and how do we get there? So there's a lot that's been going on. This shows the ribbon cutting for the ceremony and the fact that next year it's going to be in Indianapolis. So I hope many of you there join us in Indianapolis in November for the Global Buried Asset Management Congress. And so what are we really talking about? What we're really talking about in asset management is moving from reactive to being proactive. In other words, not waiting for things to break, but trying to do what we can to determine the condition, the mechanisms of failure, the rates of deterioration, so that we can determine when things need to be done to predict catastrophic failures. A lot of benefits come from having a program like that. We're able to do things that can increase the life of the assets and decrease maintenance, because we're able to get in there and take care of things in a timely manner at the right time, decrease the capital cost. Really just helps us make sure that we're spending the right amount of money at the right time, at the right place, so that we can have be able to implement the best business practices. That last bullet is also important. I try to emphasize this with utilities, municipalities that I work with, is to, as you assess your organization, try to see if there's assets that can be utilized to increase the revenue stream, so that asset management is not perceived as just a cost expense, but also the opportunity to look at ways to increase the revenue side of asset management. The things that we do are not new. In the United States, the thing that really started making us focus on what the treatment systems need to do and what we need to do as far as the collection systems and distribution systems started with the Clean Water Act in 1972. So the things that we're doing are still trying to comply with the Clean Water Act and things like that. Along the way, there's been other programs called capacity management, operation, and maintenance that were implemented through EPA and also through the General Accounting Office, things that will help us to determine the value of our assets. So there's a lot of things that's happened on the local and state and federal level, and even worldwide, to help us develop these principles and practices to take advantage of managing these things better underground to prevent these kind of catastrophic failures. And interesting enough, we're seeing these kind of failures increase at a escalating rate. So we have these major advantages. I'm not going to go through all of those. Some of them are intuitively obvious, but a big part of what we're doing in order to manage our assets gets into this right here, the location and mapping. And that's why I'm tying preventing cross bores with asset management, because if we do a good job in developing these asset management plans and programs, then we're also at the same time simultaneously doing things that's going to prevent and identify cross bores in our system. But there are many benefits and that we have here. But the main thing is just knowing what we've got and where it is. All along the way, and all that we do, I keep emphasizing that we've got to focus on the path that we need to be on. This came out in the research project that we were doing with EPA, is that in every area of the organization, we need to be thinking about not just technical innovations, but innovations in the way that we do business, and being able to validate the things that we're trying to evaluate and put into place. And of course, education at every level. And that becomes more and more important as we see people like myself get in a position where we're going to have to turn over the reins to the younger generation. So we've got to make sure that we're preparing them for the next leaders in our industry as well. So asset management, let's look at it. Now these are the 5 core components established by EPA over 20 years ago. And it really hasn't changed. Many publications, many documents, but the fact is, these core components really are at the heart of asset management. So we have the first one being current state of our assets. And then 2 gets into understanding the services that we need to provide, the levels of service. What's critical? What are those critical assets in our system? And then how to really utilize the principles of minimum life cycle costing and long-term funding. So those are the main components that we've got to address in trying to develop the asset management programs. Just take a look right here at the current state of our assets and what's involved with that. First of all, we've got to know what we've got, the inventory. Then we've got to understand the mapping. Then we've got to understand the condition and understand the solutions. So those are the 4 major components that make up the first component here on asset management. But it's the foundation. It's the foundation of what we've got to do. But here, knowing what we've got, the inventory in our system, but also mapping, the location and mapping, that's the really major challenge of trying to put together the plan, is determining where it is. And so that's how asset management can tie into things like dealing with cross bores. And when we think about innovation in those areas, in that particular area, we've got to think about subsurface utility engineering as being a key part of really determining where things are. And then we've got to also look at the condition of those pipelines and assets, and look at solutions for them, and then put all of that into some type of data management system or software system that can help us in determining what we need to do and what is it going to cost us, and what it ended up costing us, and being able to put together the plan. So these are key aspects of the plan. So what are we really talking about with subsurface utility engineering? It gets into the location and mapping, and there's a lot of different parts that go into it. What we've been able to do here with Purdue and BAMI and ASCE is put together schools, 5-day schools that really teach what this standard is all about. So when you look at these two standards, some of you, I'm sure, are very familiar with them. Both of these are 38. This one came out, was published in 2002. This one came out, was published in 2022. 20 years went by. And what we saw in that 20 years was the design community, the design engineers did not embrace the principles that are taught in these standards as we thought they would when we were developing them. So what we've done as a result of that is put together a 5-day school that can really teach these principles. So when we think about when we think about damage to underground utilities, cross bores being a part of it, we realize that in the United States, every state has state laws that deal with damage prevention. You dial before you call before you dig, the 811 numbers. But what has happened is we continue to see the strikes increase every year. So we've really got to embrace the ASCE standards that really help the design, the designer understand where these utilities are. So we do that with these standards, which provide a definition to suit, the quality levels and details and examples and so forth. Much information and knowledge is based in these things. So we don't need to be reminded of what we're dealing with the underground infrastructure. So we typically have under our streets a maze of utilities, and often the ownership and location is not known until we have something like this, until we have a catastrophic event take place. Unfortunately, I've had the opportunity to serve as an expert witness in some of these explosions, and it's not a pretty sight. They have to deal with loss of life and loss of property as a result of unknown location of utilities. But there's more to it than that. It's reported that about 70% of construction projects are impacted by underground utilities. It's a serious business because it impacts the budget, it impacts the schedules of 70% of the projects. So we're paying for it. So the risks are great. The impact of these events are great, from project delays to the cost of doing the work, a lot of extra work that goes into as a result of the risk of unknown underground utilities. So what we try to do with ASCE 38 through SUE is really take that total risk and try to apply it to the individuals or the companies that are best suited to take that risk. So we have the design engineer taking part of it. These are the 4 quality levels that we're dealing with. So we start out with D, C, B, and A. And so as we move through the SUE process, we see that this design engineer is taking less and less risk. The SUE professional, who is licensed and trained to locate and map these utilities, take more and more of the risk. And and at the same time, what we're doing is really eliminating a lot of the risk. So one of the studies that was done a long time ago was actually done by Purdue University, and it was done probably 25 years ago, but it was telling us that for every dollar spent on SUE, there's a savings of about $4.62. But the fact is, there's been additional studies that's been done that says that financial benefit is much larger than this. It gets on up to about $9 or $10 for every dollar that's spent as a result of the damage. So there's about, with the utility engineering becoming more and more important to us, there's basically 6 pillars that make up utility engineering that's got to be part of our asset management program. And that's coordination, the investigation, conflict management, and planning and design, construction, and then managing those assets. So these are the what's referred to as the 6 pillars of utility engineering. And that takes us from being able to, from the concept of the project all the way into managing it once it's built out. So there's a lot that goes into it, a lot that we need to learn. And so I know that we're limited on time. So Sergio, we can stop right here, or we can move with some more information. Would you like to stop here and go into questions and answers? So, okay. Okay, that's a good, that's where I'm going now. So real quickly, as we go into these, look at these issues, then knowing the uncertainty becomes very, very important to us as the designers. So it helps us in being able to move the project from concept to construction, and we can develop, design the project that is constructible by knowing better what's underground. So with that, it takes us into really looking at how to deal with the underground infrastructure. So ASCE 38, you may have already covered this. We talk about the 4 levels of uncertainty that we deal with in ASCE 38. And so that's the core component of the school that we put on, that's referred to as the Utility Investigation School. And so this is put on through ASCE Utility Engineering and Surveying Institute. This is ASCE here. And BAMI becomes the main coordinator of putting these schools on. We have a agreement with ASCE to utilize materials that has been developed through their risk management division. So this is photographs of schools that we've done before. The schools are made up of 5 days. The 3 days are in the classroom, and then 1 day we call field day, and that's what you're looking at here. This is actually in New York when we were doing it with the New York University. And this is where Sergio, I don't see Sergio in this picture, but he's out there somewhere. But these are other schools, one in Denver and so forth. But the idea is 3 days in the classroom, working with the documents. We go into a lot of detail on case studies and the legal aspects related to knowing your underground infrastructure. In America, the state of Colorado passed a law that stated that any engineer designing a project that has excavation on it must use ASCE 38. So we're seeing more and more states realize that just having
How about the 29th?
damage prevention is not enough. That they've got to, damage prevention has got to start with the design engineer.
Yeah. What did I have? 1:30. That sounds fine. 1:30, April 29th p.m. Okay, thank you.
So anyway, I think somebody's bleeding in here. So we have done these. We have worked with other organizations in Latin America. We have not put on a 5-day school there yet, but we have helped them develop their own two-day school on ground penetrating radar and mapping. And we do the certification of it. We train the instructors and certify the attendees. And that's what we're doing here in Columbia. So basically what we're doing is continuing to do everything that we can to advance the ability to locate things underground, from guesswork to utilizing witching rods to now utilizing multi-channel sensors. And So what I would like to conclude with is that our team is very interested in bringing this school, this 5-day school, to Brazil, and we have talked to Sérgio about that, and we feel like that this would be something that could really help advance not only asset management but also ability to deal with things like cross bores and other types of impacts that can come from not knowing where the underground utilities are. Sérgio, with that, I'm going to turn it over to you and answer any questions that may have arisen. Okay. Okay. All right, glad to be with you. Appreciate the opportunity to share these thoughts with you. Thank you.
Fazer um pequeno intervalo agora, só que são 5. É no outro? Mais um? Tá pronto aí? Nós temos aqui 2 perguntas. A primeira delas, como ocorre o gerenciamento de redes abandonadas e qual a responsabilidade das concessionárias por informar os solicitantes sobre elas. Eu fiz um treinamento sobre redes abandonadas dentro do aeroporto Kennedy. Né? Foi muito interessante porque a gente imagina que o aeroporto Kennedy seria uma preciosidade, né? Então o treinamento lá foi exatamente para mostrar todas as redes abandonadas lá. Então nós não temos uma legislação no Brasil e tampouco nos Estados Unidos. Então o que o Instituto está propondo, o Instituto, a Associação dos Engenheiros, né? Esse grupo todo que está se apresentando hoje para vocês, é que a gente reúna todas as entidades que utilizam o subsolo e todos os parceiros que de alguma forma têm que intervir no subsolo. O que o Tom Eisley propôs aí já há alguns meses era trazer esse curso que ele dá lá para o Brasil. Então esse curso é um curso com uma certificação em 4 níveis, né? E a gente teria a oportunidade de entender como lidar com as redes abandonadas e também com as redes em carga e conhecidas. Nós tivemos alguns acidentes agora aí na região do Mercadão, né? E foi muito interessante porque há 5 anos atrás a DRC descobriu uma rede em carga da Enel, que a Enel não sabia. Então ela descobre a rede às 2 horas da madrugada, consegue evitar um acidente, né? E 5 anos depois, agora questão de algumas semanas atrás, o empreiteiro conseguiu acertar a rede e logo em seguida, no dia seguinte, acertou novamente. Então eu acho que esse é um problema mundial, não é um problema do Brasil, né? E o esforço é nesse sentido, é convencer todo mundo a dar uma atenção especial. A outra pergunta é por que não temos uma única célula de fornecimento do cadastro no Brasil? Isso foi a primeira tentativa que foi feita há 25 anos atrás. Amanhã a Abratt celebra 25 anos de existência, a Associação Brasileira de Métodos Não Destrutivos. E a primeira decisão, juntamente com a Comgás, com a antiga Telesp, com a Sabesp e com a Prefeitura de São Paulo, no Convias, sob o comando do Romano, foi feito um grupo de trabalho que era um grupo de prevenção de danos, hoje reproduzido pela Comgás num outro grupo que se chama NCO, núcleo compartilhado de obras. E a Prefeitura de São Paulo, na época, eu posso testemunhar porque eu era o presidente da Abratt, não aceitou a colaboração da Abratt, né? A ideia nossa era aproveitar o que os Estados Unidos tinham feito, que era uma legislação federal, para atender esse propósito aqui. Essa legislação existe lá ainda hoje, é chamada de One Call, e nós traduzimos essa legislação há 25 anos atrás, submetemos à apreciação da Prefeitura de São Paulo, mas ela alegou que ela tinha condições de fazer todo o mapeamento por conta dela. Eu não vejo nenhuma chance de que isso aconteça no próximo século. A única esperança que eu tenho é que a gente comece a fazer alguma coisa, né? Nova York, com 220 milhões, ainda não sabe onde estão as redes. Então, vamos cair na real aqui, né? Mas vamos começar a trabalhar. A outra pergunta é como foi realizado o cálculo econômico, né? Eu vou ter que passar essa pergunta para os dois professores, né? Os dois têm a mesma informação, os dois trabalharam nesse levantamento, e as duas universidades, tanto a Purdue, onde está o Tom Eisele, quanto a Universidade Estadual do Arizona, que é onde está o Sam. Eu prometo uma resposta, só que depois eu queria que quem fez essa pergunta pudesse preencher os dados aqui, ok?
Ô Sérgio, só fazer um comentário na questão de gestão de ativos, né? Eu vejo uma preocupação na questão de saber onde estão as redes, mas tem uma preocupação maior que eu vejo, né? E como estão operando essas redes, né? Hoje a gente aqui na ABES, dentro da nossa Câmara Técnica de Eficiência, de Gestão de Perdas e Eficiência Energética, a gente defende que a gente precisa ter um cadastro operacional, que quase que a totalidade não tem um cadastro operacional, não sabe exatamente como está operando. Eu acho que esse é um primeiro passo, né? Não só das redes de água, de esgoto, drenagem, gás. Eu acho que daí sim juntar isso num único documento, né? Então eu acho que esse é um movimento que precisaria ser reverberado.
Nós começamos esse movimento, né? E deixo até aqui eu mudei o nome do S-Built. Mudei ele para S-IS. Então, ele deixa de ser como foi construído para eu entender como ele está. Essa seria realmente o grande primeiro desafio. Um município se dispôs a fazer isso, que é o município de Campinas, porque ele tem 100% de água potável distribuída e entregue, e tem 90% de esgoto coletado e tratado. Então, o município de Campinas está universalizado. A Comgás tem também lá no município um centro operacional, assim como a cidade de Campinas tem um belíssimo centro operacional na Sanasa. E então há um trabalho em andamento, lento ainda, mas em andamento, para que a gente consiga montar um projeto piloto dentro do que você falou. Lógico, dentro da minha responsabilidade na ABES, como eu sou do Centro Paulista, que é a área que abrange a região de Campinas, eu estou totalmente envolvido lá. Estou como, vamos dizer assim, estou mais ou menos como Ariano Suassuna, porque um dia falaram para ele que ele era pessimista, né? Aí eu acabei de falar, agora precisa de um século, eu acho que não. Eu não vou ver. Eu, com segurança, daqui umas semanas, faço 80 anos, não vou ver isso realizado. Mas o Ariano Suassuna falou, não, cara, eu não sou pessimista. Eu sou um realista esperançoso. Então, eu sou aqui um realista esperançoso dentro da proposta que você falou. É lógico, dentro da ABES eu espero ter receptividade, e quando eu trouxer o pacote aqui para dentro, tenho certeza que a ABES vai encampar esse objetivo aí.
Vamos para o próximo, Sérgio?
Vamos.
Hello, and welcome to today's talk about demystifying asset management, and thank you all for listening. Asset management at its core is a thought process.
Alô? Essa próxima apresentação é da Ritter Hilmenberg. Ela é professora da Universidade de Novo México e ela começou a se dedicar nos Estados Unidos à gestão de ativos, a desmistificar a gestão de ativos. Porque é normal você chegar na concessionária e o cara fala, isso tem que gastar muito dinheiro, isso é muito difícil, nós não temos verba, né? E a mesma coisa lá. Né? Então não é nem falar se os Estados Unidos têm mais ou menos recursos. Então ela se dedicou praticamente nesses 20 anos a estudar uma forma de simplificar a gestão do ativo. É sobre isso que ela vai falar.
Hello, and welcome to today's talk about demystifying asset management, and thank you all for listening. Asset management at its core is a thought process, and there's a lot of technology we can add, like computerized maintenance management systems and asset management systems and SCADA systems and Internet of Things and digital twins and asset management plans and strategic asset management plans and many others. But where's the thinking part? We can get too caught up in the complexity and sophistication of the technology that we're using that we lose the beauty and simplicity of asset management in the process. There are two foundations of asset management that I want to mention. One is the idea that just because we've always done it this way means we have to do it this way forever. And the other one is that asset management really means to be asking questions, making connections, and solving problems. I mean, that's really what it's about. We want to solve problems that we're having and use asset management to do that for us. So let's use an example. This is a real-world example of somebody asking a question and us using asset management to help solve the problem. So this is a question from a wastewater line crew member. And he said, we clean this one sewer line every month, year after year. It's an awful job, and we wish we could solve the problem another way. So let's start out with what is the problem? The problem is there's a sag in the sewer line. It's in a downtown area. There are restaurants and things nearby. So in this pipe, the fats, oils, and grease will fill up the pipe. It'll clog it up. And if they don't clean it out every month, then it could create a problem where it backs up into the businesses or overflows on the street and can cause problems. And they've determined that it takes about every month cleaning it to keep that from happening. So what are the triple bottom line issues associated with this problem? And triple bottom line refers to financial, environmental, and social. So financial is the cost of the cleaning. So what does it cost us to clean this pipe every month with the crews, with the equipment, all of that? Environmental, we can have potential overflows of sewage on the street or back up into businesses, which is really not good. We can have potential violations at the treatment plant where this material is going. And when they clean the pipe out, if the people don't go to the plant and dig this fats, oils, and grease out, that's where the violations come from. And then they have to dispose of that material that they dig out at the treatment plant. So we're having to dispose of the fats, oils, and grease that are removed. In terms of social, that's always related to people. There's a big job frustration associated with this. So the crew members that have to do this every month, and it takes 4 crew members doing this, are very frustrated. There's a high, what I personally call the pain in the ass factor. So the idea that this is such a difficult thing, it's a really unpleasant job, nobody wants to do it. There's an opportunity cost because there's 4 people doing the cleaning and there's 2 crew members at the wastewater treatment plant digging the material out. So there's 6 people that are spending time every month, and there's an opportunity cost, meaning those people can't be doing something else. And there's disruption to the traffic every month. So they have to block off a portion of the street while they clean the sewer line, and it takes the better part of a day to get this whole thing done. So is there anything else that could be done other than monthly cleaning? So I threw the question back at this individual and said, what could you do instead? And a very simple solution emerged. We could replace that piece of pipe and we could make the pipe straight. so that we don't have the sag in it anymore, and then we wouldn't have to do our monthly cleanings. So if we wanted to make a case to upper management and say, okay, instead of cleaning every month and keeping the sag in the line, we want to replace that portion of the pipe, what data would be necessary to make a case for a different action? So we would need data related to the cleaning. So how many man hours does it take? How many trucks do we need? What are the costs of the trucks and the man hours? What are the man hours at the treatment plant? And what is the cost at the treatment plant? For the replacement, we need to know the length of pipe we have to replace, the cost of replacement, and this is the full cost, like all of their expenses. And years of payback would be something we want to calculate to see how long it would take to spend as much money cleaning as what the cost of replacement. So if we look at the cost of cleaning, the estimated total for the year is about $15,600 to clean that pipe annually. And that's both at the treatment plant and in the street. The cost of replacement at their cost of replacement is estimated to be $37,800. So it's pretty easy to calculate the payback period, which in this case is about 2.5 years. So if we had this data and you think in your own mind, what would be your choice? What would you do? What's the best option? And maybe I should mention that it had been at least a decade of cleaning prior to this point, and it was no end in sight of when they could stop doing the cleaning because they have to keep doing it every month, and maybe it would have even gotten worse over time. So if you know that information, the best option really is to replace the pipe. The payback period is pretty short, 2.5 years, and we've already paid for that pipe over and over again. And again, there's an opportunity cost where we could put those workers on something else if they weren't having to do this every month. So what keeps people from making a better decision? So in this case, it seems rather obvious once the data is shown that yes, we should replace the pipe rather than continuing to clean it, but that decision hadn't been made. And many decisions like this aren't made. So what keeps people from doing that? So I think one of the big things is lack of asking the question. So you need somebody to ask the question, what should we do instead? Or do we have to do this all the time? So the first thing is just ask the question. The next part is, did anybody listen when people ask? So if somebody asks the question, is upper management, is a boss, is a supervisor listening to staff when they ask the question? And then we need data to analyze the situation. So do we have a way to get that data? Where can we find that information? And we want to make a case based on data. So we don't want to just say, because I hate this job, we should find another way. We should say, okay, what does the data tell us? What is the data saying about, is this the right choice or should we do something different? And also we have to think about operating dollars and capital dollars as the same. So in this case, a cleaning operation is an operation cost, and replacing the pipe is a capital cost. Those are coming out of different budgets in this case. And that happens a lot in the United States where it does come out of different budgets. And perhaps your utility looks at it that way too. We want to make sure we don't view them differently, that it's better to keep an operating expense and not do a capital expense, because in asset management, we want to view these dollars the same. We want to have the most efficient operation, whether it's operating or capital dollars. We want it to be the most efficient operation and not worry about capital versus operation. And the biggest reason I think is that because we've always done it this way, we have to do it this way, that people believe that to be the case, that you can't make changes. When we talk about buried assets, I think simplicity is all the more important. We can't see the assets, so we have to use what we have and build from there. Our pipes are telling us a story. We just have to listen to them. So what's this pipe telling us? So here I am walking down the street in a utility, and the arrows are pointing out places where there are pavement cuts in the street where they have made repairs. So there are 7 repairs on the street in this short section that I'm walking along. So they've really reached a point where the repair process is not working for them anymore. It's reached steady state and they can't even pave it fast enough before they're making the next repair. So what if we add some data about timeframes and on the screen, you'll see little blue dots show up where the breaks occur. And this is time lapse. So you can see at the beginning, the breaks are not coming as fast, but then they start coming faster. So the one story that this pipe is telling us is that there is a faster break rate over time, and you'll see some more dots pop up, you know, a couple in succession. And ultimately we have 7 breaks on this piece of pipe, and it's a fairly short piece of pipe. So what if we add a little more context? So in red right now is the pipe that we were looking at, and you can see pipe breaks over a big portion of the system. It's not the whole system, but a portion of the system. And other than this one other pipe, which clearly was even worse, the pipe we were looking at was the worst performer for the last 7 years. So we have 2 pipes in this area that are bad. Our pipe is the second worst, actually. So let's go back to our original question. What story is this pipe telling us? So it's telling us that pipe repair is no longer effective. The underlying pipe structural integrity is just not there anymore. The pipe is getting worse over time. It's one of the worst pipes in the system, and basically it's time for replacement. So continuing to do repairs is not the best option. We need to move along and do replacement. Let's look at another example. So combining questions and stories. So we have a lot of pipe. It's the same age, the same size, and we can't replace it all. What do we do? So this system was looking at a lot of pipe in one area that was all 75-year-old cast iron pipe, 6 inches. And they were saying, we want to replace all of it because it's reached the end of its useful life, but we can't do it because we don't have the money. And our take is that generally speaking, you don't replace pipe because it reached age. You replace pipe because it's not performing anymore. So what information do we have to go on? They did have a database of 15 years worth of break data. It wasn't really being used for anything, but at least they were still adding data to it. So it did have things like address, date discover, work order numbers, and various things like that. So the strengths and weaknesses of the data, it was 15 years worth of data. Some location data existed. Dates were available of when the pipe repair happened or pipe break happened. There was a pipe size through a code. However, locations were only addresses, street addresses. They weren't GIS. So that gave us a little bit of trouble trying to plot the breaks. There was inconsistent use of the codes in the system, and the codes were how we found pipe size. So that was a bit tricky. And then some codes that were in the system, nobody knew anymore what they even were. And there were no details about the breaks in terms of what type of break or anything like that. So we were looking for more parts of the story. There were no GIS maps, but there were PDF copies of as-built drawings. And you can see on the screen, it's not the easiest drawing to read. It's very dark. So we took those drawings and adjusted them using some software to make them a bit more readable. And we made copies, printed copies of the maps, color-coded the pipe type and size to make it a bit easier to create the GIS map that we ultimately made. We also placed locations of breaks on a GIS-based map. We did color code them by size. And one of the issues was that we used address matching software, and it's not going to be perfect because the pipes are in, often cases on one side of the street or the other. There might be 2 pipes in the same area, and you have to make a choice of which pipe that break was on. So sometimes it was a little tricky to figure out, tie the breaks to the pipes, but we did the best we could, and it was the only data we had. So you just have to work with what you have. And we were interested in one particular area in the system. And again, in this particular area, all the pipe, 75 years old, 6-inch cast iron pipe. And we combined all the information we had about break data and color coded by the number of breaks in the pipe. And the blue pipe that you see is pipe that has had 0 or 1 break. And then the brighter colors like the reds, the oranges, the yellows are when there's way more breaks in the pipe. So you can see that there are 2 places in the pipe where there were a lot of breaks. So one of them was this area where there were 13 breaks, and breaks were increasing over time. If you looked at data for break rates, the breaks were increasing over time. The other area was this area where there's a big bend, and there were a huge concentration of breaks around the bend of that pipe. So 2 pipes really require immediate attention, and those are the ones with 23 and 13 breaks. And they could be replaced right away. And then you'll notice that there is an area kind of in the middle where you see like a moderate number of breaks per pipe. And that area could be watched. Maybe a few of those might need to be replaced, but mostly you could just watch that area and see what's happening. And the rest of the area was really nothing to be done. Very little was happening. So well over half of the area had no breaks or 1 break over a 15-year period. So there's really nothing that they needed to do. And this would save them a lot of money and a lot of effort because we're focusing on where the problem is, and it's not a universal problem. It's a very specific problem and one that they could address. Well, combining questions and stories in another case, we have spent the same amount on small diameter pipe replacement for a long time, over 15 years, but nothing changes. And this was back a while ago, so things have changed, thankfully. But the start was boxes and boxes of paperwork order data. And unfortunately, that was all work orders. So we had to search through thousands and thousands of paper records to find the hundreds of records that addressed mainline breaks in the system. We created an access database and GIS map of the data. The strengths and weaknesses of this data were 15 years worth of data, 12 years of paper, 3 electronic. A fair amount of detail was there. The dates were available, repair types were known, some data on why the break occurred. In this instance as well, the information did include what type of pipe, but it wasn't GPS located data. The data was extraordinarily difficult to obtain. It was inconsistent naming conventions. When we were looking through the work orders, they called pipe breaks all kinds of different things. Some records were incomplete, so you'd find the break data, but they only had filled in, or you found the work order, but they'd only filled in a few pieces of it. And then we didn't have any paper data for the first year of the electronic, when they changed over to electronic paperwork, electronic work order data. So we couldn't check the accuracy of the electronic data with the paper data, which was kind of unfortunate. So we plotted the break data on a map, and you can see pipe type is shown. And if you look at the map quickly, you can see most of the dots are red and yellow. So we'll take away everything else and just leave the red and yellow dots. Red dots are steel pipe, yellow dots are cast iron pipe, and roughly half the dots are red and slightly less than half of the dots are yellow. So that would be kind of okay if the system was half and half steel and cast iron, but it turns out that light blue in this drawing is, or in this picture, is cast iron, and the red is steel. So 5% of the system is steel, and well over about 60% of the system was cast iron. So we're having a really outsized problem with steel pipe, where half the breaks are occurring on 5% of the system. They used to replace pipe based on ease of construction and just picking like a 1-mile section to replace, starting where it was easy to do it. They changed to a criticality mode where they picked the pieces that were breaking the most and had the most consequence of failure. And that created a major improvement. So in a 5-year period, they started their asset management program in 2011. So in the first 5 years of implementing that program, there was a 45% reduction in the break rate and $9 million in avoided costs, which is serious money. So here's another case. They think they have a big problem with pipe breaks, but they didn't have any way to analyze it. So in this particular case, they had a map book, a physical map book that they would draw notes on. They had a call log that just had from 8 a.m. to 5 p.m. calls. So that would be, one tiny part of the data, and it was only for 18 months. So we put their paper maps onto a GIS format, and we also took the data that they had related to pipe breaks based on that 18 months of data. But we noticed that they thought that the worst areas was in this red circle, but there were very few breaks there. So what does that tell us? It tells us we're missing a bunch of data. So where could we get it? We found out they hadn't paved the roads in about 20 years. So we GPS the pavement cuts, and we could tell based on the location of the pavement cuts where the pipe, what pipe was likely breaking. We analyzed that to combine it, and we found places where there were lots of breaks, not too many breaks, and one area that had 27 breaks that was right outside our study area, which was really where they needed to replace most of the pipe. In this case, there was a system that had applied for $5 million to replace all their pipe. But what was their reasoning? The pipe was old and breaks a lot. When we asked them the age of the pipe, they didn't know. We ended up finding out the pipe was only about 25 or 30 years old, and the condition was unknown, but it was PVC pipe, so we didn't expect the condition to be bad. They didn't know how many breaks they had, so the project really was questionable whether it should go forward. So what data did we want? We wanted to know a bit more about the pipe breaks and why they were happening. So what did the data tell us? The data told us that they really didn't have much of a problem. There were only 5 breaks one year and 6 the next, and they really needed to do a much, much smaller project where they had to restrain a joint that was causing most of their breaks, and it hadn't been restrained before. They needed to do some loop lines and a few other things, and that would have solved their problem, and it could have and it ended up costing them $50,000 to do the project. So they saved $4,950,000 by doing something else. So simple tools were used in these cases, but mostly it was about the thinking. And that's what asset management, again, is all about. So as a wrap up, a more robust asset management program can be developed by working through the issues. It doesn't need to feel overwhelming and complex. Start simple and work up. You can use all the tools you want, just make sure they don't obscure what asset management is all about. And remember, just because you've always done it this way doesn't mean you have to do it this way. You should ask questions, make connections, and solve problems. Because even though our pipe is underground and invisible to us, it can still tell a story, and we have to be willing to listen. Thank you very much, and I'm happy to be with you today.
Põe ela, por favor. Heather, thank you very much for your presentation. I have one question. Do you have an example where this has been applied in a small municipality, for example?
Of the, hold on a minute, I'll start my video. Great. Hi, everybody. Yes, some of those examples were very small communities. So we have used this in a community as few as 50 people, all the way up to communities that have millions of people and everything in between. So this is very applicable to small communities that have 100 people, a couple hundred people. And the simpler techniques you use, the better it is for those small communities. So it can work very, very well in small communities. One community, we saved them almost $5 million by doing this type of technique. Only took us a few months to go through the data and figured out that they could do a $50,000 project instead of a $5 million project and have a better system. And that was a community of about 300 people. So this can work really, really well in small communities.
Okay, thank you very, very much. We see you at the end of this presentation, okay?
Thank you, everybody.
Ok. Ela vem aplicando essa tecnologia desde pequenas cidades com valores bastante pequenos, como $50 mil até $5 milhões, né? E nós tivemos uma experiência no Brasil muito interessante. O responsável está ali, mas ele não quer falar, é o GC da companhia da concessionária Mogi das Cruzes. Ele teve a paciência de colecionar durante 4 anos todos os reparos da cidade, né, Gessé? Infelizmente, a gente não fez uso daquele famoso banco de dados, não conseguimos utilizar, né? mas foi bem feito no padrão que a Ritter apresentou, né? Então era uma coisa bem simples e com possibilidade de um uso fantástico para a gente começar, né? O Pladevall estava me chamando a atenção ali de que a Ritter não faz uso de tecnologias mais modernas. Realmente, a gente tem muita dificuldade em implantar novas tecnologias, principalmente até nas maiores empresas concessionárias no país, né? Então, a proposta que a gente está trazendo é uma proposta de começar mais simples, para tentar chegar aonde a gente pensa que pode chegar. Eu queria também informar agora, nós vamos fazer um pequeno intervalo para poder ir ao banheiro. Tem alguma coisa para comer?
Nós temos um
também?
cafezinho rápido agora e depois no final ainda tem um outro café. É só para a gente não demorar muito em respeito aos nossos palestrantes que vão estar nos aguardando no café, para a gente continuar daqui 15 minutos, tá, pessoal? Vamos tentar manter esse horário.
Eu só tenho mais uma pergunta aqui do Emerson. Eu respondo depois, Emerson. Ok?
Então, gente, vamos lá? Então, eu queria falar um pouco da ABES, né? E falar da nossa livraria, né? Nós temos 3 livros que têm bastante a ver com o tema, né? O processo do HDD, do Pipe Bursting e o GIS, né? São 3 livros que estão aqui na nossa biblioteca, quem quiser adquirir, e que nós vamos sortear um de cada no final aqui, de quem tiver aqui, pelo número que vocês deram aqui na hora de chegada, tá bom? Então é isso, vamos para o segundo tempo, Sérgio?
Vamos. Nossa próxima apresentação, cada uma delas tem uma certa ligação uma com a outra. Eu estava explicando aqui para o pessoal que eu queria os 7 apresentadores no mesmo dia, na mesma sequência. Porque eu tinha eles, não, eu posso no mês tal, eu posso no dia tal. Eu falei, cara, se você falar sozinho num dia, no dia seguinte o pessoal talvez não lembre o seu nome. Agora, se a gente estiver todos vocês juntos numa sequência lógica, né, é muito provável que a provocação surta resultados. Então a ideia é essa daí. O que a gente tem agora? A gente tem uma apresentação do Eric Sullivan, que desenvolveu, né, nos Estados Unidos, juntamente com a turma da NASCO, uma plataforma para análise de imagens de vídeo. Os coletores de esgoto são filmados com robôs, né, e geram uma quantidade enorme de imagens. Antigamente a gente gravava isso daí em fita videocassete, né? A Otto agora? A gente gravava em fita videocassete. Agora a gente grava com robô. Tá aqui o Jorge que distribui os robôs, né? E aí a gente tem uma quantidade enorme de imagens. De posse dessas imagens, a gente tem um resultado a respeito do estado do nosso sistema de esgotamento sanitário, principalmente dos coletores de grandes diâmetros. De todos eles, um problema que preocupa todo concessionário é a declividade invertida, né? Porque você vai gastar um dinheiro para arrumar uma tubulação por gravidade e ela tem um trecho ou mais trechos com declividade invertida. Uma pessoa se dedicou a resolver esse problema, que eu vou apresentar aqui agora, é o Otto. O Otto é um belga, né, que esteve no Brasil em 2012, naquele evento que nós fizemos internacional, mas naquela época não resultou em nada, não surtiu efeito. Então o Otto vai falar um pouco a respeito do equipamento que ele desenvolveu. Na época, em 2010, quando eu conheci, o Otto ele fazia para cidades que têm tremores e terremotos. Então imagine o gestor do sistema de esgotamento sanitário depois de um tremor de terra, né? O sistema dele está à beira do colapso, né? Então o Otto desenvolveu uma tecnologia que nós vamos conhecer agora. O Otto está no ar? Hã? Bom, ele está na Malásia hoje. Eu falei para ele, sinto muito, você tem que acordar às 2 da manhã para encontrar com a gente. Se ele não estiver, também não vou ficar muito bravo, não. Tá? Põe ele aí no ar. Ei, Otto. Otto, your camera or your sound is not on.
Can you hear me? Hello?
Okay, Otto, are you hearing me?
I can hear you.
Okay. You wake up?
Sort of.
Okay, so what time is right now there?
It's 3:30 in the morning.
3:30 da manhã ele acordou para estar com a gente. We have a lot of people here to welcome you and your presentation. So I'll give you a few seconds for your initial words. Then Vinicius will run your presentation, okay?
Okay, thank you very much, Sergio. Welcome everybody. My name is Otto Valentijn. I am the Managing Director of Reduct, and we have been manufacturing gyroscopic mapping systems for any underground utility for the last approximately 25 years. In those 25 years, we have advocated feverishly that the way in which data is shared should improve. That is something that is proven to be very difficult, but we hope that with our systems and our services and our vision of what the future should look like, we can all come together as an industry and find a way of making the data and sharing the data easier, more transparent, and ultimately lead to less damage and less cost. So with that, I'll leave it for now, and I hope you enjoy the presentation. Thank you.
Thank you. Então ele colocou para a gente aqui a luta dele nesses 25 anos para facilitar a coleta de dados e o compartilhamento desses dados de forma que eles sejam absolutamente úteis e compreensíveis para a comunidade técnica. Resumidamente, lógico. Então, por favor, a apresentação dele.
Good afternoon. My name is Otto Valentijn. I'm the CEO of Reduct. We're based in Belgium, and we manufacture gyro mapping technology. I'm honored to be part of this interesting webinar and very focused, and I would like to thank Sergio and his entire SAP team for setting this up and making this possible. I hope that our contribution will also shed a different light on the issue of crossbores. And what I'll be focusing on today is the value of having an accurate as-built, or the actual location of an infrastructure, to assist or to help avoid crossbores. And in particular, I want to highlight a new feature, which means we can now remotely assess the quality of an as-built process on new trenched or trenchless pipes. So without further ado, let's start. I always like to start with this picture, because basically, let's just be clear about what happens underground. If you look at this picture, the answer is probably we don't know really what's going on down under our feet, despite the fact that there is very sophisticated technology available that will integrate the data that is stored in GIS platforms to make it virtually visible on a pad like you see here. But the quality of what you see on the pad is directly related to the quality of the data that's in the GIS. And it's the quality of the data in the GIS that is often questionable. So let's talk about some obvious questions about as-built. Is an as-built important? Sounds like a stupid question, but it is really important. And why is it important? Because if you don't know where your pipe is, it's essentially a liability, an accident waiting to happen. If you know where your pipe is, it turns into an asset, something you can work with, something you can protect, something you can operate in the way that you wish. So it's a very important piece of data of the total pipeline installation process. Do utilities assign sufficient budget to assure accurate as-builts? Well, it's my conclusion after 20 years of running Reduct that still surprisingly little focus and budget is addressed to the accurate as-built feature in the process of putting a pipe in the ground. And as a result, utilities get what they pay for. If they are very vague about how they describe how an as-built must be made and how accurate it is, a contractor has nothing to go on but to provide what is asked, which is very vague and little. So what you receive is vague and little. But that has long-term implications because that piece of data sticks with your pipe for the rest of its lifetime. So what is the accuracy that they get? Well, that can be anything from an accurate as-built, in some cases that's certainly the case, to what happens quite a lot is an as-planned. If the contractor doesn't have a more accurate data collected while he's putting the pipe in the ground, he will return the as-planned. And I can guarantee you that a very large percentage of GIS data today is actually as planned, or sometimes even worse. It's not even as planned. So, again, if you don't ask for it as a utility and you don't wish to pay for it, you actually don't know what you're getting back. So let's take a look at some of these examples in our history and cases. So here we have a 510 meter long HDD, and we mapped it, and the red line is the result of the measurement, and that's the actual true as-built. However, this was mapped 3 or 4 years after it was installed because they were going to do some work on the road, and luckily somebody in the company had the wherewithal to say, let's have this thing mapped because I don't believe the data that's in the GIS platform, because the yellow lines is what was in the GIS platform, and that is clearly not drillable, that straight, that perfect. So, they knew the data was flawed because of the perfection of it, more or less, and it turned out to be the as planned in the database. And at some spots, like in the middle of the road there, halfway down the line, you see it's more than 3-4 meters away from the as planned. Now, why that is the case is not really important. The question is, where is it? So if they do work, they don't damage your pipe. So as planned information is essentially a liability, and only as-built data makes it an asset. Now we can work with the data. Now we can tell others where to stay away from, or whatever purpose you have for it. Here is another example. This is a canal crossing, and there's 2 manholes. You see the left top picture, there's a manhole, and that's on the left-hand side. And they knew their line in the database, the GIS platform, was wrong because it entered the other manhole from the side, but they knew when they opened the lid, it was coming in from the south, where the red-yellow arrow is pointing. So they knew it was incorrect, but they did not know how they got from A to B. They had an idea that they knew it was drilled, and they thought it was something like this. Well, in essence, in reality, this is what happened. So whereas they did not make a curve to stay close to the edge of the water, they drilled all the way to a parking lot, and then trenched it back along the fence line back to the road. Now, this was done in 2013. If the original data, which is the straight line, was kept, and something happens on that parking lot, like you will see in 2022, they've now built a building there, a couple of buildings, and they were now able to at least give the data of where their pipe is. But if they had not had that remeasurement done, nobody would have known, and the risk of damage is huge. Now, when it comes to crossbores, what we're talking about here, essentially the same is is valid. If you don't know accurately where your pipe is to tell others to stay away, and you give them false data, they may be planning a route that goes straight through your pipe. So how can we assure accuracy? Well, there's a couple of options that the utility has. Intensive site supervision, but that is expensive because it requires a lot of manpower. The second problem or issue that a utility has, that they need in-depth knowledge of the technologies used to capture XYZ data. So simply prescribing a high-end technology does not guarantee accurate results. I always compare this to a simple example. If you give somebody a Mercedes, which is, according to many people, a good car, it doesn't mean you're a good driver on the road. It just says, you're having a high-end piece of machinery, but are you operating it safely or responsibly? That's a totally different question. So prescribing technology does not solve the problem either. Clear tender specifications for as-builts, that's a good start. That's where it starts. If you don't specify it in the tender as a contract, as a utility, the contractor will not execute it. You cannot rely on a contractor to always do the best he can. He will do the least he can if possible. That's my experience. But and oftentimes you cannot blame the contractor, because basically the specifications given in the tender documents is so vague, it leaves room for interpretation, and that is always a danger, because maybe the GIS people at the utility expect something different than what they get. So to summarize the utility's perspective, what do they need? An accurate as-built, delivered on time, with a consistent point frequency and point quality. That's all they want. What do they not? What distractions do they not need? Equipment management headaches, contractor performance monitoring, data quality assessment. That's what they do not need, because that requires a lot of people, it requires a lot of skills that are not part of their core competencies in-house. So, the requirements for an accurate as-built. So we already talked about the equipment. If you have good equipment, you can always have a better chance of getting a good result. But it's not everything. You need a highly skilled operator. Yes, a highly skilled operator is a plus, is an essential component in getting that accurate as-built done. But even those two pieces do not guarantee it. What you need, and what is new in essence, is the quality assessment and control. You have to assess and control what these two, the equipment and the operator, are doing. If you don't do that, again, things will start to slack. So the flaw in the classic as-built process is that the utility will have a build tender with as-built specifications provided to the contractors, multiple contractors, and the contractor provides as-built data in accordance with the specification back to utility. Now that's nice, and it's been done like that for ages, and unfortunately it has a conflict of interest, an inherent conflict of interest, in that the contractor who's installed the pipe is also the one who is allowed to make the as-built. So question is, if he or she knows something went wrong along the way or was not 100% sure, will they tell the utility, or will they provide the information that the utility wants to hear? So on the other hand, it is the most efficient way. It's very cost efficient to have the contractor do it in the field. So the question that we have is, can we keep the efficiency but assure accuracy? Well, yes, the answer is a remote QA/QC monitoring process. QA/QC stands for quality assurance and control. And how does that work? Well, in case of reduct equipment, we have set up a cloud service, and in that cloud service there is a mapping expert remotely located, not near the site, can be on the other side of the earth in essence, and they will receive the utilities as-built specs so that they have something to compare results to. The contractors use gyro mapping tools. Any gyro mapping tool that is compatible with the cloud service is possible to put into this process, into this service. And these gyro mapping tools, they send automatically performance statistics to the mapping expert, or to the cloud actually. And the expert then matches the performance to the as-built specs. and reports on a daily or a weekly basis, a pass-fail for each and every measurement done on the utilities network to the utility, with in the cases of a fail, with a recommendation of a remediation. Now that can be, sending the contractor back to do it again or whatever. Now, what is interesting about this service is that mapping expert will also immediately engage with the contractors that failed the as-built specifications to understand, first of all, why it happened. It's not always the fault of the contractor. It can be some circumstantial factors. It's good to understand for the mapping expert to understand the causes of fail. That can lead to tools being recalibrated, operators to be additionally trained, and it can also mean in some cases, like we have done here in Asia, to a slight adjustment of the equipment so that for that particular pipe, the mapping becomes a little bit more smooth. So this makes it very powerful for the utility because the mapping expert engages on their behalf with their contractors to make sure that they all start to do the best job that they can. Now, what does that mean? Let's give an example. So this is the case of a large Asian power utility. The main thing, and I will just leave it at this one thing, the main thing that the expert will consider is the spread between measurements. There's a certain standard operational procedure that we prescribe, and that provides us with spread statistics, and these give us a very good indicator of accuracy. So it's the depth spread, the Z spread, and the XY, the horizontal spread. So the blue dots are the achieved results for measurements in the month of February 2023. And the green box is where the utility, the power utility, wants to have all its results land in. So this February means it was the second month of operation of doing this service for this particular utility. So we had just started. And this means that 47 of the 47 measurements, 28 were in the green box and 19, representing 40%, were outside of the box. So the experts started engaging with the contractors, and we're now skipping to July 2023. And in that month, 75 measurements were made. 66 were within the criterion and 9 did not. Now, in the meantime, they had also increased from 4 to 7 contractors working for them. So, we've managed to get most of the results within the box. And interestingly enough, the target was to get everything in the box by the end of 2023. Now we're in the early 2024, and I can tell you that 1 or 2 measurements are sometimes still outside of the box, but most of the contractors now by themselves will make sure they're within the box, because they know if they are not in the box, they will have to go back and do it again. And that works very nicely. Also, we have, as Reduct, developed 2 additional gadgets, basically, to make the work in the field for this particular power company a little bit more easy, because sometimes the access points were difficult to reach. So we made a slide adapter so that it was easier to get to the entry points of the pipe. So it's a two-way street. It's not just bashing the contractors, it's working with the contractors and the utility to make sure the results are optimized. Here you see in a clear picture the power of the quality assurance and quality control process. Once people know they are going to be checked, they will do a better job. So, in summary, the remote QA/QC process completes the circle without breaking the bank. So the equipment, Reduct can cover all of these by now. We make the equipment. We have an academy that trains the operators, and the operators can go there for additional courses. that can be online, but it can also be physical. We have a couple of academy centers around the world. And we provide a cloud service to do the quality assessment and control, not only for our own equipment, but also for any equipment that is compatible with our cloud service. So with this, I hope I have shed a slightly new light on how to increase the quality of as-built data, which is the essence. And the as-built data is important to stop people touching your pipe, cross-boring it, or otherwise damaging it. A lot of the cross-bores are due to the fact that incorrect data is in the hands of the drilling company or the boring company, and we need to stop that. We can stop it, so we must. So with that, I thank you, and please remember that a pipe that is poorly mapped is a liability, not an asset, and Reduct turns liabilities into assets. Thank you very much, and we're open to questions.
Ok, thank you very much. Nós temos um comentário online de um colega de vocês que fala que as companhias, principalmente companhia de gás, acredito seja a Petrobras, requer que o empreiteiro faça a conferência com o georradar, né? Então, lógico, nós divulgamos todos os métodos e nós conhecemos a maioria das restrições que cada um dos métodos tem, né? Por exemplo, Marcelo teve numa perfuração, que profundidade você estava lá, Marcelo? 70 metros, 80. Em rocha, seria impossível fazer um as-built com georradar ali, né? Foi feito com equipamento de leitura. Então, lógico, métodos não destrutivos não são uma solução para todos os casos, mas nós temos que usar o método adequado para que a gente possa obter o melhor resultado das tecnologias que estão disponíveis, né? Otto, I want to thank you very much. If you can keep awake and stay with us for the end of this meeting, where you make your final comments. Is that possible, or you want to do right now and sleep?
Well, funny enough, I have another conference call starting in half an hour.
Okay. Okay, so be with us. Thank you very much.
Okay, thank you.
Bom, agora o nosso próximo apresentador é o Eric Sullivan. Então, o Eric, como eu falei no início desse bloco, ele se dedicou a construir uma plataforma para interpretação das imagens de vídeo, né, coletadas em filmagens de coletores de esgoto, principalmente grandes diâmetros, né? Lógico, a ideia é que a vista humana não consegue identificar e distinguir os 236 defeitos que existem numa tubulação enterrada de esgoto ou drenagem. Então, a ideia da plataforma foi, em primeiro lugar, ensinar a máquina a ler milhões de imagens. Então, a máquina aprendeu a ler e interpretar milhões de imagens de defeitos catalogados. E agora o que o Eric vai apresentar para a gente é de que forma a máquina lê um vídeo que vocês subiram na plataforma da SURI. Eric, how are you doing? Thanks very much for joining us.
Yeah.
Okay, so you
Thanks
can
for
make your initial comments and we'll run your presentation.
Oh, I just wanted to say thanks for the opportunity to be here. Looking forward to taking any questions if they come up. And go ahead.
Okay.
the presentation?
Yeah, it's going.
Okay. Okay, perfect. I am prepared to share a presentation. You mentioned that you had that already on your end, so just let me know what you need me to do. Thank you. Okay. I will share. I'll try to be concise. Just real quick, let me actually get the presentation to work properly. Yeah. Oh, sorry about that. Okay, I'm gonna go ahead and stop sharing here. I thought you guys had a deck of mine that you were gonna you had a recording for. Is that not the case? Maybe we should move on to whoever's next. I'm not ready. I had messages this morning with you folks, and you said that there was going to be a recording. So I'm going off of what I was told here. So I'm having a bit of an issue on my end getting the right slide deck in front of me here. Yeah, great. Sérgio, go ahead and present that if you can in Portuguese, like you mentioned. Good. Thank you, sir. Okay, I guess I'll go forward in English. Please go to the next slide. Just providing some very, very quick background on my company. Please advance one slide. Thank you. Okay, we're based in Walnut Creek, California. We've been around since 2019, and we've completed over 400,000 inspection surveys using our AI-assisted technologies, which I'll share about momentarily.
Acompanhou mais de 400 processos de inspeção de redes e tem mais ou menos 22 mil milhas, aproximadamente 40 mil quilômetros de imagens interpretadas. Seria basicamente todo o estoque de redes da Sabesp no estado de São Paulo. Ok, Eric.
Yeah, go ahead and just advance 2 more slides, please. Let's get to the issue of cross-bore itself. Yeah, 1 more, please. Another slide, please. Yeah, next slide. Great. Yeah, hopefully, yeah. So as we've covered already today, horizontal directional drilling is a beneficial trenchless technology. Unfortunately, sometimes the drills are not always aware. The drillers are aware of the existing utilities underground, and there can be a potential for conflict with existing pipes that are there, particularly side sewer lateral pipes. If you could go ahead and go to the next slide. Okay, great.
O que ele está mostrando se seria exatamente sobre os cruzamentos de redes feitos a partir do uso do método de furo direcional, e ele está comentando exatamente que é difícil manter um alinhamento e que a forma de proteger os ativos é ter uma filmagem.
Great. Yeah. So at this point, I can introduce the technology that we've been implementing in the industry here in North America. This relates to the CCTV inspections that have occurred for quite a bit of time in order to address the cross-bore safety issue. So crews are televising mainline pipes and lateral pipes and generating a lot of CCTV video. Our technology, we call AutoCode, utilizes computer vision AI to automatically identify various different types of conditions inside of a sewer and storm pipe, including cross-bore conflicts as well as related structural defects. So the AI models are trained to look through every image and identify if there's any of these types of defects in the videos automatically.
O que ele está mostrando, então, é que a máquina, a inteligência artificial, compara as imagens que ela aprendeu a interpretar com as imagens do vídeo que você subiu. Essas imagens, toda vez que a máquina identifica um defeito, ela gera um retângulo ou um quadrado, que vocês estão vendo ali na imagem, e identifica esse retângulo ou esse quadrado com o tipo de defeito e dá todas as posições. Ali indica a posição do defeito em relação ao relógio, ela indica o tipo de defeito e ela indica a gravidade do defeito baseado numa tabela de criticidade da NASCO americana, que gera um relatório com defeitos. Classificação 1, sem problemas. Classificação 5, provável colapso. Então, o relatório que o proprietário da rede recebe é um relatório completo de todos os defeitos analisados na velocidade muito rápida aí que vocês estão vendo da inteligência artificial. Go ahead, Eric.
Great. Next slide, please. Oh gosh, just go ahead and click a few times. Yeah, thank you. Keep going. Okay, great. So one important part of the process is that after the AI tools run, we review all the AI outputs with a team, an internal team of technicians that are industry certified. And those individuals make the final determination about whether or not there's a crossbore or other types of defects on a CCTV inspection.
O time da Silvereye é um time de engenheiros certificados pela NASCO americana. Uma vez que o seu vídeo sobe na plataforma, a máquina faz a interpretação e a equipe de engenheiros da Reduc faz a validação dos dados que a máquina apontou. Ok, Eric.
Yeah. Related to this is a cloud platform that we developed for the management of the inspection data and for ways. It's this, if you go to the next slide, please. Thank you. Yeah. Ways to share with different project stakeholders, inspection data, results of inspections, the existence of cross-bore conflicts, things like that, and to be able to do that inside of a GIS map environment. Also, we've integrated with several industry partners, including Esri, and I'll share momentarily about a few projects where we're utilizing this on.
A plataforma trabalha com vários programas abertos, né? De tal forma que você pode gerar vários tipos de resultados, inclusive mapeamentos em diferentes shapefiles, e com isso daí você tem uma gestão da rede televisionada mais adequada.
Great. Yeah, next slide, please. So as I mentioned, the data is captured in the field, uploaded to the cloud. That's where the AI tools go to work, followed by review from our team, and then it's made available in the cloud for submittal to customers and sharing with project stakeholders.
O vídeo sobe para uma plataforma na nuvem, é interpretado, é revisado pela equipe e aí é disponibilizado para o proprietário da rede ou prestador de serviço.
Great. You can skip the next slide, please. Please go to the next slide. Great. So I'll share a quick case study. This was a result of a large cross-bore project that occurred in Northern California with a gas utility. They provided a municipality in the area, the city of San Francisco, with data that they had collected as part of the cross-bore safety program. It was 52,000 inspections, about 1 million feet of inspection data, so roughly 300,000 meters or so. And the use case for us here was that the owner, the sewer utility, was interested in obtaining condition assessment information from those cross-bore safety inspections, which were just raw videos. So this provided us an opportunity to utilize our AI tools and our process to provide the sewer utility with useful asset management data as a result of the data collected from the cross-bore safety initiative.
Esse é um caso de um cliente deles que entregou para eles aproximadamente 289 quilômetros de rede para ser inspecionados em 52 mil vídeos, e além das informações técnicas que o programa gera, ela também gerou uma economia de horas-homem de trabalho com uma economia de milhões de dólares. Okay.
Yeah. To have done this manually, it would have taken 8,800 hours, which is about 10 years or so. If it was one person trying to do this, 5 days a week for 40 hours a week, we were able to complete the project in a matter of months, and at approximately a quarter of the cost of what it was estimated, using manual review methods comparing.
Para ser feito, eles conseguiram gerar a informação num tempo muito curto.
Great. Next slide, please. Yeah. Another project related to this was with the gas utility itself, who was interested in utilizing this technology for their own cross-bore safety purposes to enhance the program that they already had. One study that they did on the accuracy of the tools involved about 150,000 feet of inspection data. And we analyzed that data set and identified all the crossbores that they had in the data set as an example of the validity of the technology. That then led to an engagement that is currently underway with Pacific Gas and Electric, where there's roughly 15 contractors involved collecting data pretty regularly. And we are providing a cross-bore safety audit on that data.
Aqui exemplo onde, então, o objetivo seria identificar cruzamentos de redes dentro dos coletores. Nesse caso, a câmera trabalha numa velocidade bem menor do que nos outros, mas, além disso, ela procura utilizar a visão de toda a circunferência do tubo, e no programa a plataforma está preparada para indicar falsos negativos, né? Então, isso é um recurso muito importante para trabalho, e ele pode ser feito também com a câmera de empurrar, e a câmera de empurrar é a cabo, né? E isso é feito hoje com 15 empreiteiros da companhia Pacific Gas and Electric. Okay.
Yeah, and specifically what we're providing, please go to the next slide. Thank you. Is a set of checks to look at the integrity of the database, but also the optical quality of these videos. The idea being that in cross-border safety, you want to make sure that you have good data, that you can have an assurance that there, in fact, is not a conflict, and that you're able to find all the conflicts that are there. So it's a series of different checks that we provide using the AI tools, and also to ensure that the proper assets were inspected. And the cloud enables the use of a dashboard so that the different stakeholders are able to see in near real time which inspections have occurred, but also if there's issues with different inspections, providing that feedback to the contractors, in some cases having them re-televise so that the assurance can be provided that there was no cross-border.
O outro recurso que a plataforma oferece é uma integração da comunicação baseada em relatórios muito precisos, com vários recursos onde o proprietário da rede e o inspetor e o empreiteiro também podem trocar informações entre si em tempo real, com comunicações, obviamente, entre pessoas autorizadas a esse tipo de aplicação, e a pessoa rapidamente pode compartilhar dúvidas ou imagens daquilo que está sendo coletado no campo, já que é possível subir diretamente do campo para o servidor do proprietário da rede ou da empreiteira ou de quem esteja executando o trabalho. Ok.
Yep. Last slide is just a quick review. Please go to the next slide. Thank you. No, next. Nope. Yeah, one more, please. Yeah, just a quick overview of a couple of the relevant integrations as it relates to mapping of the inspections and the results of the inspections. One is with Esri, ArcGIS Online specifically. And then there's another vendor that is involved with several cross-border projects called Unearth that we've been able to integrate with. And this is a set of tools where the operators are able to locate themselves using the device and tying the inspection data to the work order and the locations on a map that they're pinpointing. And that's called Unearth Labs.
Vocês todos provavelmente já ouviram falar, muitos conhecem o ArcGIS. Então ela trabalha com essas plataformas abertas, mas também no propósito do objetivo desse webinar de hoje, eles têm um contrato com a Unearth Labs, cujo objetivo é fornecer recursos para que a ferramenta trabalhe direcionada para projetos de avaliação de cruzamentos de redes. Nós temos uma pergunta rolando aqui no nosso online, que se seria possível detectar corrosão em tubos metálicos. Sem dúvida, a máquina aprendeu a ler todo tipo de defeito. Eu mencionei, são 236 defeitos. O que ela não pode é determinar a profundidade da corrosão. Isso é feito através de outros equipamentos de EBND que nós dispomos, né? Então, identificada a corrosão e a localização da corrosão e apurar a gravidade dessa corrosão é feito com outro equipamento que vai acomodado junto ao robô, né? Então, no robô nós temos recursos para colocar equipamentos como sonar, laser e o lidar para a gente poder ampliar as análises quanto à gravidade. Ok, Eric.
Thank you very much. Yes, I am, sir. Thank you. Okay.
Of minutes more, we have one more presentation from Mark Bruce from the Cross-Border Safety Association, and then is the end of this meeting, okay? Nós temos uma outra pergunta: como que a tecnologia de inteligência artificial ajuda no cadastro de redes existentes? Aqui nós estamos falando, nessa inteligência artificial, de avaliação de defeitos nas tubulações coletadas por robôs. A outra ferramenta, que é a ferramenta mostrada pelo Otto, é a ferramenta que gera o as-built inercial. Então nós estamos com alguns trabalhos em andamento, né? E nesses trabalhos em andamento, a concessionária pediu que a gente fizesse o as-built da rede que acaba de ser construída pela empreiteira, né? Então nós estamos fazendo o as-built de redes de gás e o as-built de redes de esgoto. O as-built inercial, ele trabalha com variações da gravidade e da magnetismo do planeta. Então ele gera uma informação como o giroscópio ou paratrack, que a gente trabalha no HDD, e eu tenho uma posição exata para o as-built que é entregue ao proprietário da rede. Então vamos para a nossa última apresentação hoje. Apesar de todos esses esforços ao longo destes 25 anos, com o aumento sempre crescente de acidentes, eu trabalho a Comgás também próximo da CGA, Common Ground Alliance americana, criada há exatos 25 anos atrás, com a ideia de fazer a gestão dos usuários do subsolo, as concessionárias. Então, um número rapidamente, são 5 anos atrás, 6 anos agora, estamos em 24, nós detectamos mais de 400 mil acidentes nos Estados Unidos, com redes. Desde um acidente bem simples, onde uma pessoa vai cavar uma vala para plantar um vaso, uma flor no jardim, acerta um ramal, até os casos que vocês tiveram oportunidade de ver em algumas das apresentações. Então, a CGA apontou esse número de acidentes, no ano seguinte aumentou e continua aumentando. Então, houve a necessidade de se montar uma associação de cruzamentos de redes. Então, hoje a gente vai apresentar o Mark Bruce, já está aí? Hey Mark, how are you doing?
I'm doing great, Sergio. It's good to see you.
See you too. So we are ready for your presentation. You can make your initial comments, and then Vinicius will run the presentation that is already subtitled. So don't worry, we have your presentation, the new one, already subtitled. Okay?
That's great. I appreciate the opportunity to share the leading practices for cross-border risk reduction with the goal of reducing injuries, damages, while protecting the business value. In other words, the damages that you can have can really destroy the value of a company when you have lack of trust in the pipelines and the integrity that you put in the ground, that you can't protect it and protect the homeowners and the business owners. So welcome to the presentation.
Ele colocou que o grande foco da associação hoje é valorizar o seu ativo, né? Essa é a grande sacada de evitar os cruzamentos de rede ou descobri-los antes que eles virem um acidente. Ok.
Hello, I'm Mark Bruce. I'm president of the Cross-Border Safety Association. I look forward to speaking with you today about the leading practices for cross-border risk reduction a document that was published in February of 2020. The focus today is of gas distribution safety. The definition of a cross-bore is an intersection of an existing underground utility or underground structure by a second utility, resulting in direct contact between the transactions of the utilities that compromises the integrity of either utility or underground structure. Cross-bores are created when trenchless methods are used. You'll see on the right an HDD machine at the top, a plow on the far right, and a percussion mole on the lower right. So trenchless is a great tool. It prevents the damage to trees, shrubs. We do not have to dig up the streets to the extent, we do not have to replace as much concrete and asphalt, keep traffic flowing. And it's important for us to have this using trenchless methods. We've known about cross-bore since 1976 at least. And additionally, as time goes forward, where we have non-conductive pipelines in place, we have typically been putting tracer wires with that during the installation. But in the United States and Canada, we're finding that the corrosion of those tracer wires is causing them to be now unlocatable. So we believe that regulations should require GPS locates and mapping and GIS systems for all utilities now on. A Class 2 cross-bore is an immediate explosion risk. It's where two utilities are intersected by a third utility. And this shows a gas line, a white sewer pipe, and an HDD installation of fiber optics. It shows where the fiber optic drill head punctured through a sewer pipe about 10 centimeters in diameter and hit a gas pipeline. Well, this angular space around the HDD bore allowed that gas to flow into the sewer pipe and then onward into the house. But no one was hurt in this explosion. And it occurred within minutes, just a few minutes after the actual HDD intersected the gas pipeline. So we know here that by looking at this photo, this photo, that is catastrophic and dangerous, and we need to avoid cross-bores. Often gas pipelines are installed through sewer pipes, and they lay there for decades, many, many decades, and they are not found until much later, and often by drain cleaners. So a drain cleaner is called out by the structure owner, the homeowner, and they bring out tools that on rotating devices that spin, and these devices are made to cut roots. They're also capable easily of cutting plastic gas pipelines. It's important to let the drain cleaners and work with drain cleaners and homeowners know that there is risk. The type of device that's used for cleaning drains is a rotating device. It's shown in that top image. Below it just shows some partially plugged up sewer pipes that have cross-bores through them. So gas can migrate through pipelines, and if you have a cross-bore of a mainline sewer or even a lateral that goes and is connected in a manner that will transmit the gas through other structures, it will actually be at risk of several structures from one cross-bore with a gas line. Potential cross-bore a sewer line by a gas line is shown with these triangles. And anytime those two cross in a 2D version, we have to be worried that the elevation may be at the same point and there is an actual cross-bore. The estimated quantity of cross-bores in the United States is about, and Canada is about 0.4 cross-bores per mainline mile. And that's where there's trenchless installations. This is an illustration from a utility that has an ongoing legacy and new construction cross-bore for prevention program. So we show that the educational knowledge is decreasing cross-bores in the last decade, but we're still having cross-bores created. On the right-hand side, you'll see a table that shows of the cross-bores found, 27% were of gas mains in sewers, 73% were of gas services. When several agencies and organizations and industry leaders realized that the cross-bore inspections that were being done and installations that were using cross-bore prevention processes were still leaving cross bores behind. And the credibility of continued use of trenchless installation methods was in question because cross bores were being created and left behind, both after inspection and after new construction using good, what was thought to be good cross-bore efforts. So this would have been a major disruptor to the industry, including to the contractors, manufacturers, and utilities, if trenchless installations could not be utilized in the future. And a high confidence recommendation was needed. So Cross-Bore Safety Association and related organizations and agencies completed the leading practices for cross-bore risk reduction. Some of the organizations that were participating in that and were asked to review the documents included the American Gas Association, American Equipment Manufacturers, Distribution Contractors Association, which is a construction group, the Gas Technology Institute, National Underground Contractors Association, and several more organizations throughout the country. But the stakeholder interests were broad. We looked at public outreach, utility planners for doing the construction and for planning inspection projects, utility project managers of overall, installing contractors, inspection companies, vacuum excavation companies that were exposing potential cross-bore locations. Quality control was very extensive throughout the document. It is very extensive. Mapping requirements, drain cleaning, IT and data preservation, and regulators, rates, and requirements. We ended up with 32 chapters, 88 pages, many figures, references, and examples are in there. You'll see that this is outlined in a format that you can actually pick a chapter that's of direct interest to your requirements and what you're looking for, but it's advised that you read the entire document to get the full flavor and the interaction of all the different chapters and all the information in there. So we had this request from the regulators and the industry organizations and the industry companies, and the end results was a document that required high confidence, and it had verifiable QC processes embedded in throughout the document. So if you're starting a new cross-bore inspection program for legacy projects, you may just say, hey, we know that schools, hospitals, nursing homes, assisted living facilities, large concentration buildings where there's many people in there, and difficult to evacuate structures, which also include hospitals. Those things may be something that you want to do first. So the benefits of cross-bore risk reduction efforts include protecting the public and industry workers. And it reduces risk that is in a cost-effective manner. And this is, if you do a proactive approach to this, preventing cross-bores from being installed and eliminating cross-bores that already are lying in your sewer pipes, eliminating those from the system. That is going to be a lower cost than paying for the damage and the other related costs to an explosion or a fire. So in the practices, leading practices, there's many sections. I'll talk about those here just very briefly. But there's a history and financial and social cost area. We talk about the current practice gaps, installation of equipment at risk, results of the cross-bore in the timeline, regulatory opportunities for the agencies to have uniform processes recommended for construction and for inspection programs to ensure that cross-bores do not exist, and then regulatory rate support that gives enough money to the utilities to allow the contractors to do the inspections and to do the installations in a safe manner. There's a lot of information out there on in that document of 32 chapters. Some of the page excerpts here talk about risk modeling and prioritization of inspection programs for legacy. Also in there, it talks about some of the challenges of doing inspection programs of sewers, blockages, pipes that have sags in them, that have water that allow the cameras not to see clearly. Also, when you're having blockages and difficulty navigating that sewer, as we showed in the prior slide, you may actually have to access it from inside the structure. Validate that outside extra addition to the house that may be just a separate sewer added to the closest mainline sewer. So you may actually have two services. On the right-hand side, you will see an image on structure number 4, where there's two laterals going to one house. And also, as you do mapping and capture the geolocation of your sewer cameras as you're being transmitted through the line and capturing those GPS points, this shows an illustration of where a orange gas line is in place, and we're showing the green as where the sewer camera has transacted and been pushed through a sewer pipe. And on the upper right-hand corner, you'll show that that inspection was short, and they did not get up to the risk of the gas line. So in this case, we're able to use this GIS information to do a quality control of field work, and we find that it wasn't fully done to the extent needed. And the mapping requirements allow you to visualize where the work is being done. It verifies that work has been done fully to the extent and covered all the properties that need to be done. And then it does allows you to inspect each one of those and correlate the location and the sewer video. We'll see on the left a cross-bore report, and at the bottom you'll see the actual cross-bore. The yellow in that pipe is a gas line, and you can show where it's partially plugged up with debris. Also, just as illustrative purposes in the leading practices, we've shown examples of things that can be good communication tools. So there's a lot of cross-bore information online. The Cross-Bore Safety Association is the organization I'm representing here today. So all of this put together with good process design, good data collection that's accurate, good quality control, which verifies the field work for both construction and for inspection programs, and good data management of accessible, easily identifiable, and geolocation of that information, all will eliminate the cross-bore risk. We started out with the many organizations concerned that trenchless may not be able to continue to be used in the future because we were creating cross-bores. And even after inspection programs were done that did not have good quality control and good verification processes, we were finding cross-bores in lines. So those were leading to a potential where trenchless would not be utilized in the industry. And there was worry in the industry from both the state, federal, regulator level, organizations, utilities, and they wanted to have a good document that was and good methods recommended that could give confidence that we were not creating cross-bores, and we had methods of eliminating, improving cross-bores were not in those sewer lines. So you need to have high confidence data. And low confidence gives you false security. And I believe that can create a negative value. If you're telling people it's clear, but it's not clear of risk, that is very risky and not good. So low quality work may have to be completely redone. If you're doing an inspection program, you may have to go out and do a complete system again. And that is very, very expensive, and it does nothing for the value of the enterprises or the people that we're trying to protect. So thank you for giving me the opportunity to speak with you here. The leading practices are a tool. There's many other tools out there that relate to cross-bore risk reduction. I suggest you reach out, read those, be thoughtful about those, and have a program and design your program for construction and for legacy installations and post-construction inspections to reduce the risk of cross-bores with very, very good practices. So I know this is a virtual session. If there's any opportunity for questions, be glad to take those now. Thank you so much and have a great day.
Okay, Mark, thanks very much. We are finishing the webinar, and we'll invite all the presenters to say a few words at the end. I will start with you. So you're the last and the first.
Well, thank you, Sergio. I appreciate you guys taking a look at this. I guess the final thing to say is this document that we've done, have you translated that into Portuguese, Sergio?
It's good for remembering. Esse documento foi autorizado a ser traduzido e também disponibilizado no site da ABES amanhã. Okay.
We think it's very valuable. Yeah, good. That's great. It's more or less a recommendation of what to do. It doesn't dictate how a particular contractor or utility goes at things, but it's a recommendation. And we find that it's been pretty well accepted across the United States as we go forward. Thank you again.
Ele recomendou que seja feita a leitura, quem puder baixar o documento. Nós vamos então entregar 2 documentos, ok? O documento da PPI, o documento da Cross-Bore, e quem quiser a norma brasileira tem que entrar na BNT e fazer a aquisição, ok? Next is Ritter Himmelberg. For your final considerations, please.
Thank you for having me. And I just wanted to say that asset management can be extremely helpful to anybody, and it doesn't have to be super complicated. I just recommend getting started, and you will find ways to
we missed your sound.
What happened? Can you hear me now? Okay. So what I was saying is just keep it real simple. Start with what you know, work from there, and you will find success if you start with questioning what you're doing, how you're doing it, and see if there are better ways of doing it. You'll find enough success to keep sustaining your program. So I wish you all the luck and good wishes. And, if there are questions, I apologize that I don't speak Portuguese, but if you can ask in English, I'm happy to answer them.
Thank you very much. Ela recomendou a gente começar por mais simples que a gente comece, mais efetivo a gente será. Thank you, Heather. Next. Tom Isley, for your comments, please.
Well, I certainly concur with what Heather said regarding asset management, and I appreciate the opportunity to have been part of the program this afternoon, and looking forward to continuing to work with the group there in Brazil, particularly with the idea of bringing the Utility Investigation School to Brazil. And I think that's something that could really help in trying to minimize the risk of cross bores, and certainly help in many other ways as far as supporting the asset management program. So thank you again, and looking forward to working with you.
Thank you very much. Então ele agradeceu a participação, está entusiasmado em trazer esse treinamento de gestão de ativos para o Brasil. Nós estamos sempre em contato aqui com a direção da ABES, com os grupos. Vamos ver se a gente consegue. Thank you. Good to see you. Thanks very much for joining us. Send my regards to everybody down there. Next, Otto, for your comments, final comments, and go to sleep.
Yes, thank you, Sergio. Yeah, well, it's been very interesting listening to the other speakers as well. What is clear to me is that the solution is not one technology or one platform. It's a mix of what the industry has to offer to make the underground safe, and particularly with regard to cross bores, is to reduce them. And it's a call out to everybody who's out there in the audience to not stare at one particular solution. Look at them all, and the answer is somewhere in the mix of things. And we can surely make a contribution to making the underground safer. Thank you very much for being there today, and we hope you will see you soon in live. For questions, you can always approach Sergio or myself directly. Thank you. Bye-bye. Now I can turn it in.
De uma única tecnologia, mas sim da junção de todas elas. Então, só agradecer da minha parte aqui ao apoio da ABES, fez um trabalho fantástico em promover todas essas legendagens, em colocar esse evento no ar, né? Eu fiquei muito satisfeito, não me incomodei com o trabalho que me deu, foi uma satisfação enorme e eu espero que tenha uma continuidade. E obrigado a vocês todos.
Excelente contribuição sua aqui para o setor, né, Sérgio? Você que é um líder nessa área, né? E você lembrou bem, né? Agradecer aqui o Vinícius, né, que fez um trabalho fantástico, a Débora, toda a equipe da ABES. Sem eles nós não estaríamos aqui. Os vídeos chegaram aí na semana passada, né, Vinícius? Foi uma correria danada para a gente conseguir pôr isso em pé, mas foi um sucesso. Eu acho que agradecer aqui os nossos palestrantes, eles já se foram, né? Mas agradecer também a Abratt e a Bicom pelo apoio, os patrocinadores Comgás e Sabesp, e lembrando que todos esses vídeos vão estar, né, no YouTube, né, Vinícius? Depois, assim que ele voltar e organizar isso tudo, acho que amanhã, no máximo até sexta, isso está tudo no YouTube. O Sérgio vai passar essas normas em português para a gente disponibilizar também. E a gente dispara um e-mail de quem se inscreveu, né? Dizendo que está tudo no ar para vocês saberem a hora que estiver disponível. Agradecer a presença de todos, agradecer quem esteve com a gente online e falar de alguns eventos que nós temos pela frente, né? No dia 6 agora, eu vou entrevistar o André Salcedo, o diretor-presidente da Sabesp, sobre o processo de privatização da Sabesp. De 7 a 9 de maio nós vamos ter um congresso internacional de resíduos. A ABES tem muita coisa, gente. De 3 a 7 de junho nós teremos o Brasil Water Week, que é o mais importante evento internacional de saneamento, 100% online, 40 horas intensas de palestras e painéis. E faça a sua inscrição, já está aberta a inscrição no site. E eu estou participando de um dos grupos de organização dos painéis. Está ficando muito legal, nós vamos ter gente de quase o mundo inteiro trazendo novidades sobre as questões da água. E também de 28 a 30 de agosto nós vamos ter em Recife o 21º Silubesa, Simpósio Luso-Brasileiro de Engenharia Sanitária e Ambiental. E no último trimestre está programado um seminário nacional de gestão de perdas e eficiência energética, que nós estamos coordenando aqui, que será em São Paulo, provavelmente em novembro, tá? E também em novembro vai ter em Curitiba o 17º IWO Small Water and Wastewater System, em Curitiba de 10 a 14 de novembro. Gente, tem muita coisa, a ABES está trabalhando muito para trazer conhecimento e difundir a importância do saneamento no Brasil. Nós temos aqui um sorteio, o Vinícius vai fazer rapidinho, temos 3 livros para sortear, depois nós podemos encerrar e tomar um café juntos, né? Não dá para fazer? Você não está preparado? Te elogiei, hein, Vinícius, não vai deixar a gente na mão. Vamos começar com o HDD?
Só quem está presente.
Pode ser que o número que saia não esteja aí, né? Olha lá, o sorteio do primeiro vai para 19. Marcelo Lourenço. Tá aí? Pronto. Já levou. Gente, eu tenho o livro. Então vamos sortear outro. Pronto. Quer outro? Quer o Pipe Bursting? Também tenho. Então. Pronto. Como você foi sorteado, leva o giz. Pronto. Vamos lá, outro. 23. Miriam de Cássia Sintra Calegari. Pronto. Esse é o...
Eu vou entregar o de arrebentamento de redes Porque eles fizeram 450 quilômetros de troca de rede utilizando esse método. Eles têm 900 quilômetros para fazer, vão terminar. Há 20 anos atrás eles já acharam que era muito. Né, eu me lembro na conversa com o Marco lá, você está maluco, cara, eu não vou trocar rede. Tem 900 quilômetros. Eu falei, ué, mas se você não começar, o ano que vem eu volto aqui, você continua tendo 900 quilômetros. Se você começar, eu volto aqui e fala, agora eu tenho só 890. E ele começou, e hoje eles estão próximos de fechar 450 quilômetros. 600, né?
Manda um abraço pro Marco, hein? Obrigado por vocês terem vindo aqui, hein? O próximo, 30, é o Rodrigo Brito Barbosa. Tá aí?
Outro...
Que não. Agora tem que começar de novo.
Lembra os três saíram?
35. Ah, não, eu não posso. Pladevall não. Eu não nem sei porque eu tô na lista. Nem sei porque eu tô na lista. 2. Já foi embora. Ana Paula da Comgás foi embora. 7. Gessé Cardoso de Oliveira. Pronto, aí.
O Gessé não quis falar aqui, ele teve a paciência
levou o livro aí.
De fazer 4 anos de registro, né? Nós somos colegas de turma também, né? Fizemos engenharia, saneamento básico ambiental juntos. Parabéns.
Gente, mais uma vez, obrigado. Lembre-se que a ABES depende dos associados, a participação de vocês é importante. Virem sócios da ABES. Esse network é fantástico. Eu estou aqui há muitos anos, Padula, nosso conselheiro também há muitos anos, e é importante a participação de todos. Mais uma vez, obrigado, e vamos tomar um cafezinho juntos para fazer um network.
Um abraço a todos, obrigado.
Obrigado.